Good evening, and welcome to Sleepy Night Channel. Tonight, we explore the galaxy, with the spiral arms slowly turning in the deep silence and the river of stars flowing through the velvet dark. You can simply listen and let your mind rest. Soft bell chimes and gentle ambience continue throughout, made for peaceful nights. If you'd like more calm bedtime episodes, you can like, subscribe, or leave a short comment below. It helps this channel reach others who need something quiet at night. Now, let's begin. We begin our journey on a quiet hillside, far away from the city lights. The grass beneath us is cool and damp with dew. The air is still, holding its breath in the late hours of the night. We lie back and look up into the endless dome of the sky. Above us, stretching from one horizon to the other, is a faint, glowing band of light. It looks like a river of milk spilled across the darkness. The ancients called it the Via Lactea, the Milky Way. For thousands of years, humans have looked at this cloudy path and wondered what it was. Tonight, we do not just look at it, we travel into it. We let go of the gravity that holds us to the hill. We float upwards, light as a thought, rising through the atmosphere. We pass the layer of clouds, leaving the weather of Earth behind. We pass the moon, our silent, silver neighbor. We drift past the planets, the wandering stars of our solar system. But we do not stop there. We are going much further. We pull back, moving faster than light, zooming out to see our home in its true context. As we retreat, the sun becomes just one bright star among many. And then, the shape begins to reveal itself. The band of light we saw from Earth transforms into a magnificent, flat disk. We are looking at the galaxy from above. It is a grand spiral, a cosmic pinwheel spinning slowly in the void. The sheer scale of this structure is impossible to grasp, yet we feel its majesty. This is an island universe. A city of stars so vast that it would take light itself 100,000 years to cross it from one side to the other. It contains more than 100 billion stars. Think of every grain of sand on every beach on Earth. That is roughly how many suns are burning in this single galaxy. Each star is a story. Each star is a potential anchor for worlds. And they are all bound together by the same invisible gravity, moving in a synchronized dance around the center. We float in the silence of intergalactic space, looking down at this masterpiece. The galaxy is not solid, it is made of light and dust. We see the spiral arms unwinding from the core. They are graceful, curving structures glowing with a brilliant blue light. These are the arms of Orion, Perseus, Sagittarius. They look like the ripples in a cup of coffee that has just been stirred. The spaces between the arms are darker, filled with shadows and mystery. But the arms themselves are blazing with energy. This is where the action is. This is where the galaxy is most alive. The galaxy is not thick like a ball. It is thin like a record or a plate. If we view it from the side, it is a slender line of light with a bulge in the center. It looks delicate, almost fragile, suspended in the emptiness. Our own sun is located in a quiet suburb of this city. We are not in the busy center, and we are not on the lonely edge. We are about halfway out, tucked safely inside the Orion Arm. It is a perfect location. Far enough from the chaotic radiation of the core to be safe, but close enough to the star-forming clouds to have heavy elements for life. We are living in the Goldilocks zone of the galaxy itself. Everything we see is moving. The galaxy is rotating, but it moves with a regal slowness. It takes our sun about 230 million years to complete just one lap around the center. This is a cosmic year. The last time we were in this exact spot in the galaxy, dinosaurs were just beginning to appear on Earth. The continents were fused together in the supercontinent Pangaea. We have traveled a full circle since then. It is a clock that ticks in eons. A rhythm so slow that, to us, it looks like stillness. The space between the stars is not truly empty. It is filled with the interstellar medium. A thin soup of gas and microscopic dust is less than Hasson. 4# is greater than. Looking at the galaxy, we see dark lanes running through the bright spiral arms. These are not holes in the stars. These are massive clouds of dust blocking the light behind them. They are like silhouettes or dark rivers flowing through the forest of light. They add depth and texture to the image. Without the dust, the galaxy would just be a blinding white fog. With the dust, it becomes a painting of light and shadow. We feel a sense of belonging as we gaze at this structure. Every star we can see with our naked eye from Earth is part of this family. Every constellation we know is just a local pattern in our immediate neighborhood. We have never seen outside of this city. We are children of the Milky Way. Born from its clouds, warmed by one of its stars, drifting in its current. The vastness does not make us feel small, it makes us feel held. We are part of a massive, coherent system that has survived for 13 billion years. Spinning silently, enduring perfectly. We drift closer now, preparing to enter the spiral arms. We want to see what lies inside those ribbons of blue light. We want to visit the places where the galaxy is regenerating itself. The great nurseries of the cosmos. We glide down from the high view, sinking slowly towards the plane of the disk. Ready to explore the clouds of creation. We glide silently down from the high vantage point above the galactic disk. We enter the spiral arms, drifting into the deep, rich currents of the Milky Way. Here, the space is not empty. It is decorated with massive, glowing structures that look like celestial art. These are the nebulas, the great clouds of creation scattered throughout the galaxy. They are the nurseries where new stars are born. From a distance, they look like soft puffs of colored smoke frozen in the vacuum. But as we approach, we realize their scale is monumental. A single one of these clouds can stretch for hundreds of light years across. It is a landscape of gas and dust so vast that our entire solar system would be just a tiny speck lost inside it. The colors here are breathtaking and vivid. We see deep, vibrant reds and pinks glowing softly in the dark. This is the light of hydrogen gas, energized by the young stars hiding within. It looks like the embers of a dying fire, but it is actually the blush of new life. In other places, we see veils of electric blue. This is starlight reflecting off microscopic grains of dust, like a flashlight shining through a morning mist. The colors blend and fold into each other, creating a silent aurora that spans the heavens. We float towards a dense region known as a dark nebula. It looks like a hole in the sky, a silhouette of ink-black dust blocking the stars behind it. It resembles a mountain range or a dark tower standing against a bright background. Inside this cold darkness, something profound is happening. Gravity is working its slow magic. It is gently pulling the dust particles together. Atom by atom, grain by grain, the cloud is collapsing inward on itself. It is a process that takes millions of years, happening in total silence. As the material gathers, it begins to spin and heat up. Deep in the center of the gloom, a protostar is forming. A baby sun, wrapped in a blanket of dust, waiting for the moment it will ignite. We drift past giant pillars of gas, standing tall like cathedral columns. They are being sculpted by the powerful winds of nearby stars. The radiation from these massive suns erodes the cloud, carving out intricate shapes and valleys. It looks like a canyon made of vapor. At the tip of each finger-like pillar, a new solar system is trying to survive. It is a delicate balance between destruction and creation. The violence of the universe is creating something beautiful. Yet, everything happens in slow motion. To our eyes, the cloud is perfectly still, frozen in a moment of majestic calm. The dust in these clouds is not just waste, it is the seed of everything. It contains carbon, oxygen, and iron. The very building blocks of planets and people. Every atom in your body was once floating in a cloud just like this one. We are looking at our own history. Before the Earth existed, before the sun shone, we were just dust drifting in the dark. It gives us a feeling of deep connection. We are not separate from the galaxy, we are made of it. Sometimes, a shockwave passes through the cloud. Perhaps from a distant supernova exploding miles away. This gentle push is often the trigger that starts the collapse. It wakes the cloud up from its sleep. It reminds us that the galaxy is an ecosystem. The death of an old star provides the spark for the birth of a new one. It is a perfect, closed loop of recycling. Nothing is ever lost. Everything is just transformed. We watch a cluster of young stars that have just cleared away their dusty cocoon. They are dazzlingly bright, shining with a pure diamond-white light. They are siblings, born from the same cloud at the same time. For now, they travel together in a loose group. But over billions of years, they will drift apart, lost in the currents of the galaxy. Our own sun has long since lost its brothers and sisters. But here, we see the family still together, huddled close for warmth in the cold expanse. The space inside the nebula feels thick and protective. It shields the young stars from the harsh environment outside. It is a sanctuary, a quiet corner of the universe where life begins. We rest here for a moment, bathed in the soft pink glow of the gas, feeling the potential energy all around us, the promise of future worlds waiting to be born. It is a place of infinite possibility. We leave the colorful clouds of the nebula behind and drift out into the open ocean of the galaxy. Around us, the darkness is punctured by billions of points of light. From the surface of the Earth, stars look like identical white pinpricks, varying only in brightness. But here, traveling amongst them, we see them for what they truly are. They are a diverse population of majestic spheres, each with its own color, size, and personality. It is a cosmic forest, filled with ancient giants and newborn saplings standing side by side. We glide past a star that glows with a deep, rich, ruby-red color. This is a red dwarf, the most common type of citizen in our galaxy. They are small and cool, burning their fuel with incredible efficiency and patience. Because they are so careful with their energy, they will live for trillions of years. These little red stars are the quiet survivors of the universe. They will keep shining long after the sun has burned out and long after the other lights have gone dark. They are the last embers that will keep the galaxy warm in the distant future. Because they are dim, we cannot see them with our naked eye from Earth. Our closest neighbor, Proxima Centauri, is one of these shy red stars. It sits just next door, yet it hides in the darkness, visible only to our telescopes. There is a humility to them. They do not seek attention, they simply endure. Further along, we encounter a spectacle that is the complete opposite. A massive blue giant dominates the space around it. It is a monster of a star, shining with a blinding electric blue intensity. It is thousands of times brighter than our sun, pouring out energy in a reckless torrent. These stars live life in the fast lane. They burn through their fuel at a voracious rate, shining brilliantly, but only for a brief cosmic moment. While the red dwarf lives for trillions of years, this blue king might only last a few million. It is a brief flash of glory in the timeline of the galaxy. But in that short time, it shapes everything around it. Its powerful winds push away the dust and light up the nebulas we saw earlier. Between these two extremes, we find the steady yellow stars like our own Sunday. They are the yellow dwarfs. They are the middle children of the galaxy, balanced perfectly between the calm and the chaos. They burn with a steady golden light that is stable for billions of years. This stability is rare and precious. It allows time for planets to cool, for oceans to form, and for life to take a foothold. Looking at a yellow star feels like looking at a warm hearth in a cold room. It feels like home. It is a reliable anchor in a shifting universe. As we travel, we notice that many stars are not alone. In fact, being solitary like our Sun is somewhat unusual. Most stars in the galaxy come in pairs. These are binary systems, where two suns are locked in a gravitational embrace. They orbit around a common center, waltzing through space together. Sometimes, the two stars are equals, identical twins spinning in symmetry. Other times, a massive giant is paired with a tiny dwarf, is less than her own. 4# is greater than imagine standing on a planet orbiting such a pair. You would see two suns rise in the morning, perhaps a red one and a yellow one. Your shadow would be double. It is a partnership that lasts a lifetime. We pause to look at the surface of a nearby star. It looks like a solid ball of light, but it is actually a raging ocean of plasma. We can see the surface bubbling and churning like a pot of boiling honey. Huge loops of magnetic energy arc up from the surface, twisting and snapping. Yet, despite this violence, the star holds its shape perfectly. It is held together by hydrostatic equilibrium, a perfect standoff between two immense forces. Gravity is trying to crush the star inward, while the nuclear explosions in the core are pushing it outward. They cancel each other out exactly. The result is a stable sphere, a masterpiece of balance suspended in the void. Some stars we pass are old and tired. They have swelled up into red giants. They have exhausted their core fuel and have expanded to swallow the space around them. They glow with a soft orange hue, like a lantern running low on oil. They are shedding their outer layers, puffing them gently into space. This is the planetary nebula, a beautiful shell of gas that looks like a smoke ring. The star is giving its body back to the galaxy, returning the materials so that new stars can be born later. It is a peaceful resignation, a quiet end to a long, bright life. The sea of stars is vast and deep. There are more stars in the visible universe than there are grains of sand on all the Earth's beaches. Drifting among them, we feel a sense of abundance. The galaxy is not empty space sprinkled with a few lights. It is crowded with energy. It is alive with fire. Yet, because of the distances, it remains silent and still to our eyes. A frozen firework display that never fades. We drift away from the blinding surface of the stars and move into the cooler, quieter spaces that surround them. For a long time, we thought our solar system was unique. We thought the Sun was the only star with a family of planets circling it. But now we know that the galaxy is teeming with hidden worlds. Almost every star we have passed on this journey has its own collection of planets. They are the silent partners in the cosmic dance. We cannot see them easily because they are lost in the glare of their parent stars. They are like fireflies flying next to a searchlight. But they are there, revealed only by the tiny shadow they cast when they cross in front of the light. We approach a star that looks slightly different from our own. Orbiting incredibly close to it is a massive planet, far larger than Jupiter. This is a hot Jupiter. It is locked in a frantic embrace with its sun, completing a full year in just a few days. The heat here is unimaginable, but from a distance, it has a terrible beauty. The planet is tidally locked, meaning one side always faces the fire and the other always faces the dark. Winds of ruby-colored gas roar around the equator, redistributing the heat. It is a world of storms, but from where we float, it looks like a calm, glowing marble. Further out, in the deep quiet, we find a different kind of world. A super-Earth. It is a rocky planet, but twice the size of our home. We glide over its surface. It might be covered entirely in a global ocean, a water world with no land in sight. The waves here would be massive, driven by the thick atmosphere. Or perhaps it is a carbon planet, where the pressure is so high that the mountains are made of diamond. It sounds like a fantasy, but the galaxy is creative. Nature has tried every possible combination of rock, gas, and ice. We move to a very special region around a gentle yellow star. We are looking for the Goldilocks zone. This is the narrow band of space that is not too close to the fire and not too far in the cold. It is just right. Here, water can exist as a liquid, flowing freely across the surface. We see a small blue dot floating in this habitable zone. It reflects the light softly. It looks fragile against the backdrop of the void. It reminds us of the incredible luck of our own position. To be perfectly placed. To be warm enough to live, but cool enough to have oceans. It is a delicate balance that the galaxy maintains with precision. The movement of these planets is a masterpiece of mechanics. Gravity acts as an invisible tether, a long rope swinging the planets around the center. There is no friction in space to slow them down. Once a planet is set in motion, it will continue to spin for billions of years. It is a clockwork mechanism that never needs winding. The planets do not crash into each other, they stay in their lanes. They respect the rhythm of the system. It is a silent waltz. Turning and turning in the dark, perfectly synchronized. Drifting further out, away from the warmth of the stars, we encounter the ghosts of the galaxy. These are the rogue planets. They are orphans that have been kicked out of their solar systems by gravity. They do not orbit any sun. They drift alone through the interstellar darkness. It seems lonely, but there is a peace to their existence. They are not bound to anyone. They are free travelers, moving silently through the shadows between the stars. They are the dark ships of the cosmos, carrying their secrets quietly through the night. We look at the massive gas giants that guard the outer edges of the systems. They are planets made of atmosphere, with no solid ground to stand on. They are striped with bands of ammonia and hydrogen clouds. Great storms the size of continents rotate slowly on their surface. These giants play a protective role. Their massive gravity acts like a shield. They catch the stray asteroids and comets that might otherwise hit the smaller inner planets. They are the big brothers of the planetary family, taking the hits so that the smaller worlds can sleep safely. Even the planets have their own companions. We see moons of ice and rock circling the giants. Some are covered in smooth ice sheets, hiding oceans underneath. Others are volcanic, turning themselves inside out. It is a system within a system. Wheels within wheels. Everything is orbiting something else. Nothing is truly static. But the motion is so smooth, so repetitive, that it feels like stillness. It is the rocking of a cradle, steady and sure. We turn our gaze away from the open space of the spiral arms and look towards the center of the galaxy. We are traveling downtown towards the galactic core. As we glide closer to the middle, the scenery changes dramatically. In our own neighborhood, the stars are far apart, separated by light years of empty darkness. But here, the stars begin to crowd together. The sky becomes a blazing tapestry of light. If you lived on a planet near the core, you would never know true night. The sky would always be filled with thousands of suns, brighter than the full moon, casting shadows from every direction. It is a city that never sleeps. We enter the galactic bulge. This is the massive spherical hub of the Milky Way. The stars here are different from the ones we saw earlier. They are not the young blue stars of the spiral arms. They are the ancient ancestors of the galaxy. Old, golden, and red giants that have been circling the center for 10 billion years. They move in chaotic, swarming orbits, like bees buzzing around a hive. There is a sense of history here. These stars remember the very beginning of the galaxy. They are the original foundations upon which the rest of the structure was built. The dust here is thick and heavy. Great clouds of interstellar material wrap around the core like a veil. For centuries, astronomers on Earth could not see into this region because the dust blocked the view. It was a hidden, forbidden city. But now, we pass through the veil. The light is warm and yellow, glowing like an old street lamp in the fog. The radiation is intense, but from our safe distance, it just looks like a golden haze. It feels dense and significant. We are approaching the throne room of the Milky Way. At the very center of the swarm, there is a point of absolute darkness. Everything in the galaxy is orbiting this single invisible object, It is Sagittarius A star, a supermassive black hole. It is a gravity well so deep and so powerful that not even light can escape its grip. It is 4 million times heavier than our Sun, crushed down into a singular point. It sounds terrifying, but here, in the silence of space, it is peaceful. It is not a vacuum cleaner sucking everything in. It is simply an anchor. The stars orbit it safely, just as the planets orbit the Sun. We watch the stars nearest to the black hole. They are moving at incredible speeds, whipped around by the immense gravity. They complete an orbit in just a few years, racing against the curve of space-time. But the black hole itself sits quietly in the middle. It is the eye of the storm. Around it, a disk of hot gas swirls and glows, waiting to fall in. But the event horizon itself is a perfect black sphere. A shadow in the middle of the fire. It is the ultimate silence. A place where time and space come to an end. This black hole is the reason we are here. Its gravity helped to shape the early galaxy, pulling the gas clouds together so stars could form. It is the seed around which the pearl of the Milky Way has grown. It is a heavy, stabilizing presence. Like a keel on a ship, it keeps the galaxy steady as it sails through the universe. It holds the spiral arms together. It keeps the rotation uniform. It is the dark heart that pumps life through the veins of the galaxy. We realize that time flows differently here. Near such immense gravity, time actually slows down. A minute near the event horizon could be years in the outside world. It is a place where the clock stops ticking. The black hole is timeless. It watches the stars are born, live, and die while it remains unchanged. It is the eternal observer, sitting in the dark, waiting for the end of eternity. We back away slowly, respecting the power of the core. The golden light of the bulge begins to fade as we retreat to the suburbs. The crowd of stars thins out. The silence returns. But we carry the knowledge of what lies in the center. The galaxy is not just a random collection of lights. It is a structured kingdom with a powerful ruler. A ruler that rules not with commands, but with gravity, holding us all in its long, invisible arms. We drift away from the bright, golden bustle of the core, moving back out into the quieter regions of the spiral arms. As we look at the galaxy spinning below us, we notice something strange. By all the laws of physics we know from Earth, the stars on the outer edge should be moving slower than the stars in the center. Just like planets further from the Sun move slower than planets close to it. But they are not. The stars on the lonely edge are racing through space just as fast as those in the crowded middle. They are moving so fast that they should be flying off into the emptiness, flung away like water from a spinning wheel. But they stay put. Something is holding them. Something invisible and immensely heavy is gripping the entire galaxy, keeping it locked together. We are entering the realm of dark matter. It is the ghost in the machine. We cannot see it, we cannot touch it, and it does not reflect any light. But we know it is there because we can feel its gravity. For every ounce of bright, shining star stuff we can see, there are 5 ounces of this dark shadow stuff hiding in the background. The galaxy is not just the flat disk of light we see. It is actually a massive sphere, a giant halo of dark matter that engulfs the visible stars completely. The shining spiral we admire is just the decoration in the center of a much larger, invisible ball. It is like looking at lights on a Christmas tree at night. You see the lights, but you cannot see the tree that holds them. We float in this invisible ocean. It is a comforting thought. The universe is not filled with empty space. It is filled with structure. This dark matter acts as the cosmic glue. Without it, the galaxy would tear itself apart. The sun would be lost in the void. The structure of our night sky would dissolve. This invisible web is the guardian of stability. It has been holding the shape of the Milky Way for billions of years, silent and unseen. It is the strong, quiet hand that cradles us. This web extends far beyond the boundaries of our own galaxy. It connects us to our neighbors. There are filaments of dark matter stretching across the intergalactic void like bridges. Galaxies tend to form along these lines, like dewdrops forming on a spider's web in the morning. We are part of a vast, interconnected network. A cosmic web that spans the entire universe. It means that nothing is truly isolated. Even in the deepest emptiness between the stars, there is a connection. A pathway that links the small blue dot of Earth to the furthest reaches of space. We look closely at the halo surrounding the galaxy. It is not completely dark. Drifting through this lonely outer sphere are the globular clusters. These are tight, spherical balls of stars, some of the oldest objects in the universe. They hover above and below the galactic disk like satellites. Each cluster contains hundreds of thousands of stars, packed together so tightly that they move like a swarm of bees. They are the ancient travelers. They have watched the spiral arms form and dissolve over eons. They are the keepers of the galaxy's memory. While the disk is busy making new stars, the halo is a place of quiet preservation. A museum of the early cosmos. The silence here in the halo is profound. We are far away from the noise and radiation of the star-forming regions. The stars here are few and far between. If you stood on a planet in the halo, the sky would be mostly black. You would see the great spiral of the Milky Way hanging in the sky like a giant, glowing painting. It would cover half the heavens. A magnificent view that no human eyes have ever seen. It is a place of solitude and perspective. Looking down at the busy city from a quiet mountain top. watching the great wheel turn, slowly and majestically. We realize that what we see with our eyes is only a tiny fraction of reality. The universe is mostly hidden from us. It is a mystery that wraps around us like a velvet blanket. But this mystery is not scary. It feels supportive. We are floating in a sea of invisible matter that keeps us safe. Gravity is the only language it speaks. We continue our journey outwards, floating past the halo, past the lonely globular clusters, and into the deepest of deep space. We are leaving the Milky Way behind. Looking back, our home galaxy looks like a shining silver disk suspended in the dark. It is beautiful and complete, a solitary island of light in a vast ocean of emptiness. But as we look around, we realize that we are not completely alone in the universe. We are part of a family. A small collection of galaxies huddled together in the void, bound by the invisible ropes of gravity. This is the local group. A cosmic village containing more than 50 galaxies, moving together through the expanding universe. Hovering close to the Milky Way, like moths circling a street lamp, are the satellite galaxies. The most famous of these are the Magellanic Clouds. We drift towards them. They do not have the perfect, organized spiral shape of our home. They are irregular galaxies. They look like chaotic, glowing clouds, smears of paint on the canvas of the night. They are much smaller than us, but they are bustling with energy. They are the younger siblings of the Milky Way. Trapped in our orbit, they have been circling us for billions of years. As they pass close, the gravity of the Milky Way pulls at them, stretching them out. A long stream of gas, the Magellanic Stream, trails behind them like a ribbon, connecting the satellites to the parent. It is a bridge of hydrogen gas flowing silently through the dark. We turn our gaze further out, peering through 2.5 million light-years of silence. There, glowing softly against the black, is a magnificent shape. It looks like a mirror image of our own galaxy, but larger and grander. This is Andromeda, our big sister. It is a massive spiral, containing perhaps 1 trillion stars, twice as many as the Milky Way. From Earth, it appears as just a faint, fuzzy smudge in the constellation of Andromeda. But here, in the space between worlds, we see its true glory. Its spiral arms are tightly wound. Its core glows with a fierce golden light. It is majestic and imposing. A giant sleeping in the distance. Andromeda is special because it is moving. While most galaxies in the universe are rushing away from us as space expands, Andromeda is rushing towards us. We are falling towards each other, drawn together by mutual gravity across the intergalactic void. It is a slow-motion approach that will take 4 billion years to complete. It is not a collision in the way we think of car crashes. Galaxies are mostly empty space. When they meet, the stars will not smash into each other. They will pass through the gaps, like two ghosts walking through each other in a hallway. It will be a great merger, a cosmic dance where the two spirals will swirl around each other, mixing their stars. Eventually, they will settle down to form one giant elliptical galaxy, a new super galaxy, Milkomeda. But that is a story for the very distant future. For now, Andromeda is just a beautiful light on the horizon, watching us, waiting for us. The space between us is vast and clean. There are very few stars here. It is the intergalactic medium, a vacuum far more perfect than anything we can create on Earth. Yet, even here, there are solitary atoms of hydrogen drifting alone. 1 atom per cubic meter, floating in the absolute cold. It is the quietest place imaginable. A silence so deep it feels sacred. We look around at the other members of our local group. The Triangulum Galaxy, a smaller spiral that spins quietly nearby. And dozens of tiny dwarf galaxies that hide in the shadows. They are all moving together through the universe. We are like a raft of islands drifting on a dark ocean, separated from the rest of the universe by enormous voids. The nearest other group of galaxies is millions of light years away. This isolation makes our neighborhood feel cozy. The distances are huge, but they are bridgeable. The light from Andromeda reaches us. The gravity of the Magellanic Clouds touches us. We are connected. We realize that the sky at night is a window into the past. When we look at Andromeda, we are seeing it as it was 2 million years ago. Before humans walked on Earth, that light began its journey. It has been traveling across the empty space while civilizations rose and fell. And it arrives at our eyes only now. The universe is a time machine. Every glance upwards is a glance backwards. We are surrounded by ghosts of light. History is written in the beams that cross the dark. The stability of the local group is a comfort. Even as the rest of the universe expands and galaxies fly apart from each other, our group will stay together. Gravity here is stronger than the expansion. We will hold onto our neighbors. We will keep our family close. In the far, far future, when the rest of the universe has faded from view, the Milky Way and Andromeda will still be here, dancing together in the dark. A single warm island of light surviving in the cooling cosmos. Our journey through the grand spiral of the Milky Way is drawing to a close. We have traveled from the bright, crowded core to the silent, dark halo at the edge of the universe. We have seen the birth of stars in the colorful nebulas and the slow, graceful dance of the galaxies. Now, we gently pull our awareness back from the vast distances of intergalactic space. Out of the countless dazzling galaxies scattered across the cosmos, let's zoom in on our very own cosmic neighborhood, the Milky Way. The Milky Way is a galaxy, which is a huge family of stars held together by gravity. It also holds gas and dust and many invisible things we cannot see directly. From where we live, inside that family, we see it from the side. That is why it looks like a long band instead of a full spiral shape. We are not outside it, looking in. We are inside it, looking through it. The name Milky Way comes from the way it looks to the eye, like spilled milk or a faint river of light. Many cultures told gentle stories about this bright path in the sky. Some saw it as a road for souls, or a trail left by a divine figure, or a bridge between worlds. Even before modern science, people noticed how it arcs across the heavens and shifts with the seasons. The same calm band has watched over human nights for a very long time. If you could travel far away and look back at our galaxy, you would not see a simple line. You would see a wide, flat disk with spiral arms, like a slow, graceful pinwheel. Near the middle, there is a brighter central region called the bulge. Around everything, there is a much larger halo where old star clusters and faint material drift. The Milky Way is not a small object in space. It is vast enough that light needs about 100,000 years to cross it. A light year is a measure of distance, not time. It is how far light travels in 1 year. Light moves incredibly fast, yet across the scale of a galaxy, even light takes a long time. When we look up at the Milky Way, we are often seeing stars as they were long ago. Their light has been traveling through space for years, and sometimes for thousands of years, before it reaches our eyes. The night sky is a calm kind of time machine. Our solar system sits inside the Milky Way's disk, not near the center, but not at the very edge either. It rests in a quieter neighborhood between major spiral arms. The Sun is one star among countless others, and it travels around the galactic center in a slow orbit. That orbit takes a very long time, far longer than a human lifetime. In the time the Sun completes one full circuit, life on Earth has changed in deep and dramatic ways. The band of the Milky Way looks brighter in some places because we are looking toward regions where stars are more crowded. It looks dimmer in other places because dark dust clouds block the starlight behind them. Those dust lanes are real structures made of tiny grains of carbon and silicate mixed with cold gas. Dust may sound like something small and simple, but in space, it shapes what we can see. It also helps new stars form by cooling and gathering material into denser clumps. In many photos, the Milky Way looks richly detailed, with bright clusters and dark streaks. Cameras can collect light for a long time, so they reveal more than the human eye can in a single glance. Our eyes are wonderful in the dark, but they are still limited. That is why the Milky Way can feel faint to beginners and breathtaking to photographers. Both views are true, just in different ways. The sky is always offering more than we can take in at once. Over time, people learned that the Milky Way is made of stars. One key step came with the telescope, when observers saw that the cloudy glow breaks into countless points of light. Later, we learned that our galaxy is only one among many galaxies. What seemed like the whole universe was actually a single island of stars. Beyond it, there are other islands scattered through space in every direction. The universe is wide, and our home is one calm part of it. Up close, the Milky Way is not a smooth thing at all. It is full of star clusters, glowing nebulae, and cold clouds that hide what lies behind them. A nebula is a cloud of gas and dust in space. Some nebulae glow because nearby stars light them up. Some shine because they are being energized by hot young stars, and some are dark, seen as silhouettes against the brighter background of the galactic band. Stars are born inside cold, dense clouds, often called molecular clouds. In the quiet interiors of these clouds, gravity slowly gathers gas into pockets that become hotter and denser. When the center of a pocket becomes hot enough, a new star begins to shine. This process can take millions of years, which is slow on a human scale. Yet across a galaxy, new stars are forming all the time. The Milky Way is not frozen in one age. It is gently renewing itself. Young stars often form in groups, not alone. That is why we see open clusters where hundreds or thousands of stars share a common origin. Over time, these clusters can spread out as they orbit, and their stars mix into the wider disk. Some clusters remain bound for a long time, especially the older, denser globular clusters. These globular clusters are like ancient beads around the galaxy, holding some of the oldest stars we know. They remind us that our galaxy has been shining for billions of years. Meanwhile, stars are not all the same. Some are hot and blue-white, burning their fuel quickly. Some are cooler and red, glowing gently for a very long time. The Sun is a middle-sized star, not the largest and not the smallest. Many stars in the Milky Way are smaller than the Sun, and some are so faint we cannot see them with our eyes. There are also giant stars that are much larger and brighter, though they tend to live shorter lives. In the galaxy, size and lifetime often trade places. Underneath it all, gravity is the quiet organizer. It holds stars in orbit around the galactic center. It shapes the disk, the bulge, and the halo. It also gathers gas into arms and waves, creating patterns that look like spirals from far away. Those spiral arms are not rigid shapes like solid spokes. They are more like slow-moving traffic patterns, where gas and stars bunch up, then move on. As material flows through these regions, it can trigger new bursts of star formation. Farther out from the bright disk, there is a halo that extends well beyond what we see in starlight. In that halo, there is less gas and fewer bright stars. Yet the halo matters, because it holds old clusters and it reflects the galaxy's long history. The halo is also where we think a great deal of dark matter is found. Dark matter is not seen directly, but we infer it from how galaxies rotate and how they hold together. It is a quiet reminder that the universe contains more than light. When scientists measure how fast stars orbit at different distances from the center, they find something surprising. The outer parts of galaxies rotate faster than they would if only visible matter existed. That is one reason dark matter was proposed, as an unseen mass that adds gravity. It may form a vast, invisible envelope around the galaxy. Even though we cannot see it, it may be one of the main things shaping the Milky Way's structure. Sometimes, the most important parts of a system are the parts you cannot touch. If you follow the Milky Way band across the sky, you are looking along the plane of the disk. The plane is like the galaxy's main floor, where most stars and gas are found. Looking away from that plane, the sky can appear darker and less crowded with stars. That does not mean space is empty in those directions. It simply means the disk is thinner there, and the halo is much more sparse. Even emptiness has a texture when you learn how to see it. In the southern sky, the Milky Way can look especially bright and rich. That is partly because the galactic center region is easier to see from many southern locations. In the northern sky, it is still there, but different parts of the band are higher or lower depending on the season. The Milky Way does not rise and set the same way for everyone. Your latitude and your local horizon shape what you can see. The galaxy is shared, but the view is personal. The galactic center lies in the direction of the constellation Sagittarius. In a calm way, you can think of it as the heart of the spiral, where stars are more densely packed. The center is hard to see in visible light because dust blocks the view. But in infrared and radio waves, we can see much more. Different kinds of light pass through dust in different ways. That is why astronomy uses many kinds of light beyond what our eyes can detect. Near the center, there is a compact object called Sagittarius A*, which is understood to be a supermassive black hole. A black hole is a region where gravity is so strong that not even light can escape once it crosses a boundary. This may sound intense, but it does not pull in the whole galaxy like a drain. Stars orbit the center because of gravity, much like planets orbit a star. The black hole is massive, but the Milky Way is far larger still. Even in deep space, balance and orbit are the calm rule. We know Sagittarius A* is there because we can track the motion of stars near the center. Those stars move fast in tight paths, as if they are circling something heavy that we cannot see. Over years, astronomers have watched their orbits and mapped them with great care. This is one of the gentle joys of science, patient observation, gathered slowly until a clear picture forms. The universe rarely reveals itself all at once. It prefers to be understood over time. Beyond the center, the Milky Way's disk contains many spiral features. We often describe several major arms and smaller spurs and branches. Our solar system lies in a smaller feature, sometimes called the Orion Arm or Orion Spur. It is a calm place compared to the crowded center. The night sky we see is shaped by our position, like a traveler describing a forest from within it. We do not see the forest's full shape. We see paths, clearings, and the way light filters through. The gas between stars is called the interstellar medium. Even though space feels empty, there is still material there, especially in the disk. Much of this gas is hydrogen, the simplest element. Hydrogen can glow in radio waves at a special frequency called the 21 centimeter line. By listening to that signal, astronomers can map hydrogen across the galaxy. It is like tracing a coastline in the dark by listening for waves. Not all maps are made with eyes. There are also regions where gas is ionized, meaning electrons have been stripped away by energetic starlight. These glowing regions can form around hot, young stars and can appear as bright nebulae in photos. In calmer terms, they are places where new light is shaping the surrounding cloud. Over time, winds and radiation from stars can sculpt pillars, bubbles, and arcs. The galaxy is not only a collection of stars, it is also a landscape of clouds shaped by light and time. Some of the most famous nebulae we see in the night sky are within our own galaxy. They appear in certain seasons, depending on your location. They can be nurseries, where stars are forming, or they can be remnants of older stars that have reached later stages of life, returning material back to space. In this way, the Milky Way recycles. Elements made in stars can become part of new clouds, new stars, and new worlds. The atoms in our bodies were once part of ancient starlight. If you imagine the Milky Way as a living system, one slow rhythm is the cycle of matter. Gas gathers into clouds. Clouds form stars. Stars shine and change. And later, material returns to space, ready to be used again. This does not happen quickly, and it does not happen everywhere at once. It happens in pockets and waves, across a disk that is always in motion. The galaxy is calm, but it is not still. Starlight is not the only glow in the Milky Way. There is also faint light from dust warmed by starlight, especially in infrared. There are energetic signals in X-rays from hot gas and compact objects. There are radio signals from gas clouds and magnetic activity. Each kind of light carries a different story, like different instruments in a quiet orchestra. When we combine them, we understand more. And when we do not understand yet, we learn patience. The Milky Way has a magnetic field, though it is weak compared to the magnets we know on Earth. Still, across vast distances, even a weak field matters. It can guide charged particles and shape the way cosmic rays move. Cosmic rays are high-energy particles traveling through space, often from energetic events. When they meet Earth's atmosphere, they can create showers of particles. Most of the time, we never notice them. Yet they are one more quiet thread connecting us to the wider galaxy. If you have ever seen a meteor, a shooting star, it did not come from the Milky Way's distant stars. It came from a tiny piece of rock or dust entering Earth's air. But those small grains can be part of larger cycles too. Some dust in our solar system may carry ancient material from before the sun formed. In that sense, even a tiny spark in the atmosphere can be linked to an old cosmic history. The galaxy is large, and still it leaves soft fingerprints close to home. Our galaxy likely contains many planets. We find planets around other stars by watching tiny changes in starlight or subtle wobbles in a star's motion. We have discovered thousands of exoplanets, and we now know planets are common. Some are large and close to their stars. Some are small and rocky. Some orbit in regions where temperatures could allow liquid water, depending on the atmosphere. The Milky Way may be full of worlds, quietly turning in the dark. When we look toward the bright band, we see more stars because we are looking through the disk. But in that same direction, dust also hides some light. This is why the Milky Way can look patchy. The dark regions are not empty holes. They are clouds in the foreground, blocking what lies beyond. If you could see in infrared, many of those gaps would fill with stars. Sometimes what looks like absence is simply a different kind of presence. Long before modern cameras, people learned to read the Milky Way's path across the year. In many places, the brightest part of the band becomes more visible in summer nights, when Sagittarius and Scorpius are higher in the sky. In winter, other constellations and other parts of the disk come into view. The sky's slow rotation changes what stories it tells. And even when city lights hide the band, it is still there, arching above the clouds. The galaxy does not disappear. It simply becomes harder to notice. Light pollution makes the night sky brighter, which reduces contrast and hides faint stars. That is why the Milky Way is best seen from dark, rural areas or high mountains. Even a small amount of extra light can wash out the delicate glow. Your eyes also need time to adapt to darkness. After several minutes, you can see more detail. This is a gentle lesson the night teaches. Give it time, and it opens up. The same is true for learning about the sky. Astronomers once debated the size of the Milky Way and the sun's place within it. For a long time, many assumed the sun was near the center. Later, evidence showed we are not central at all. We are out in the disk, one star among many. This shift in perspective is both scientific and calming. It reminds us that we do not need to be at the center to belong. In a galaxy, a quiet edge can still be home. Beyond our own galaxy, there is a small group of neighboring galaxies called the local group. The Milky Way is one of the larger members. Another large member is the Andromeda Galaxy, which is the nearest big spiral galaxy to ours. Andromeda is far away, but it is visible to the naked eye under dark skies as a faint smudge. Its light has traveled for a very long time to reach us. When you see it, you are seeing another island of stars across a deep ocean of space. The Milky Way and Andromeda are moving toward each other, slowly drawn by gravity. Far in the future, they are expected to pass through one another and merge into a new, larger galaxy. Even a collision between galaxies is mostly empty space passing through empty space. Individual stars rarely crash into each other. Instead, their orbits change, and the shape of the combined system slowly settles over time. On the scale of the universe, change can be vast and still gentle. Closer to home, the Milky Way has smaller companion galaxies. Two of the most famous are the Large Magellanic Cloud and the Small Magellanic Cloud. They are visible from the southern hemisphere as bright patches in the sky. These companions are not just visitors. They interact with our galaxy through gravity, and their motion can stir gas and shape streams of material. The Milky Way is not alone. It is part of a quiet neighborhood with slow dances of orbit and attraction. There are also many tiny galaxies that orbit the Milky Way, called dwarf galaxies. Some are faint and hard to detect, and we often find them by looking for subtle groupings of old stars. These small galaxies can be slowly pulled apart by our galaxy's gravity. Their stars can stretch into long streams across the sky. In this way, the Milky Way has grown over time, partly by gathering smaller companions. A galaxy is not only born once, it also changes through long, patient history. If you picture the Milky Way's disk, you can imagine it as thin compared to its width. Most of its stars are concentrated near the plane. Above and below, the density drops. But even within the disk, stars are not evenly spread. There are clumps, clusters, and associations. There are also moving groups, stars that share a similar path because they formed together. The galaxy has structure at many scales, like ripples within ripples. Our Sun has its own motion through the local neighborhood. It travels with nearby stars that share a similar orbit around the center. From our viewpoint, the sky seems fixed, but over long times, star positions change. This is called proper motion, the slow drift of stars across the sky. Most changes are too small to notice in one lifetime, but they are real. The constellations are not eternal. They are temporary patterns in a moving sea. When we look at the Milky Way, we see only a fraction of its stars. Many are too faint, many are hidden by dust, and many are on the far side of the disk, their light dimmed by distance and absorption. To learn about the whole galaxy, scientists build models and maps using many kinds of data. They measure distances to certain stars by parallax, which is a small shift in position as Earth moves around the Sunday. They also use standard candles, stars whose brightness is understood well enough to estimate distance. Mapping a galaxy from inside it is slow work, but it is possible. There are special stars called Cepheid variables that brighten and dim in a regular rhythm. Their pulse rate is linked to their true brightness. By comparing true brightness to how bright they look, we can estimate their distance. Another useful group is RR Lyrae stars, often found in old clusters. These methods helped build the first real sense of our galaxy's scale. Each technique is like a quiet tool, turning scattered points of light into a coherent picture. Science, at its best, is a calm kind of listening. Inside the disk, gas can form long lanes and shells. Sometimes, groups of young stars blow bubbles in the surrounding gas with their winds and radiation. These bubbles can expand until they meet other bubbles, creating complex shapes. In some regions, the edges of bubbles can compress gas and trigger new star formation. This is a slow chain of creation, like gentle waves spreading across a pond. The Milky Way's star formation is not random. It often follows patterns created by earlier generations. Many stars are born with disks of material around them. In these disks, dust grains can collide and stick, slowly growing into larger bodies. Over time, this can build planets, moons, and smaller objects. Not every disk forms a full set of planets, but the process is common. When we see young stars in our galaxy, we often find evidence of these disks. In a quiet way, it suggests that the ingredients for worlds are spread widely. Our own solar system is one example among many. The Milky Way also contains regions where stars are very old. In the halo and in globular clusters, many stars formed early in the galaxy's history. These stars tend to have fewer heavy elements, because they formed before many generations of stars had enriched the gas. In astronomy, metals means elements heavier than hydrogen and helium. These heavier elements are made inside stars and spread out when stars shed material. Over billions of years, the galaxy becomes richer in these elements, making rocky planets more likely. Time, in the galaxy, builds complexity. If you think about the elements in your everyday life, many of them have a cosmic origin. Carbon, oxygen, nitrogen, and iron are formed in stars. The calcium in bones and the silicon in rocks are also products of stellar processes. The Milky Way is not just a backdrop above us. It is part of our deep ancestry. We are made from material that has traveled through star cycles and cloud cycles. That can be a comforting thought, like belonging to a much larger story. Beyond visible stars, the Milky Way contains many objects that are difficult to see directly. There are brown dwarfs, which are like stars that never became hot enough to shine strongly. There are also stellar remnants, like white dwarfs, which are dense cores left behind after a star has used much of its fuel. These objects can be faint, but they still have mass and still orbit within the galaxy. The Milky Way is full of quiet things. Not everything announces itself with bright light. When the night is very dark, you may notice that the Milky Way seems textured, almost like a soft fabric. That texture comes from both stars and dust. In some regions, there are dense star fields, where stars appear like a gentle spray. In other regions, dark lanes cut through the glow like calm shadows. Your eyes may not separate every star, but your brain senses the richness. It is one reason the Milky Way can feel soothing to watch. It offers detail without demand. If you have binoculars, the Milky Way becomes even more interesting. You can see clusters that look like small, bright clouds. You can see star fields that seem endless. You can also notice that some stars are actually multiple stars close together. Many stars form in pairs or in systems with several stars. The Sun is a single star, but many others have companions. In a galaxy, companionship is common. Some parts of the Milky Way include large, star-forming regions that can be seen as hazy patches even without magnification. These regions can contain both bright young stars and dark, cold clouds. As stars form, they can light up their surroundings, creating glowing shapes. Over time, those same stars can disperse the cloud that formed them. It is like a quiet story of birth and departure, played out over millions of years. The galaxy carries many stories at once, each on its own slow schedule. In the quiet background, there is also the movement of the whole galaxy through space. The Milky Way is not fixed in a cosmic frame. It moves relative to other galaxies and to the background of the universe. Our local group has its own motion, influenced by the gravity of nearby clusters and large-scale structures. Even the largest things drift. The universe is not a still picture. It is a gentle flow of motion over deep time. Sometimes, the Milky Way can be seen reflected in calm water, or framed by trees, or stretched above a desert. These views can feel poetic, but they also carry a simple truth. The galaxy is overhead wherever you are. If the sky is dark enough, it does not belong to one country or one era. It is a shared ceiling for all of Earth. When you watch it, you are participating in a very old human habit, looking up and wondering quietly. If you live in a city, you might feel like you have lost that view, but even then, you can still connect to it in other ways. You can learn the constellations that remain visible. You can watch the moon's slow phases. You can visit darker places when you can, and let your eyes adjust. The Milky Way has waited billions of years. It will still be there when you find time to look again. Some things are patient beyond measure. Beyond what we can see, our galaxy has layers of history. Stars carry chemical signatures that tell us what kind of gas they formed from. Their motion can hint at where they came from and whether they were part of an old merger. Some stars in the halo may have belonged to smaller galaxies long ago. Their presence is like a quiet record, written in orbits and elements. In this way, the Milky Way is an archive. It keeps its memories in starlight. Astronomers also study the galaxy's shape by measuring how stars move. In the disk, stars tend to orbit in a fairly ordered way, like a calm rotation. In the halo, motion is more scattered, like a spherical swarm. These patterns help us separate different components of the galaxy. They also show that the Milky Way is not a simple, single object. It is a layered system with parts that formed in different ways. Complexity here is not chaotic. It is structured and slow. Some of the Milky Way's spiral structure is still being refined in our understanding. Because we are inside the disk, it is hard to draw a perfect map of the arms. Dust blocks some views, and distance estimates have uncertainty. Yet the broad picture is clear, a spiral galaxy with ongoing star formation in the disk and older stars in the bulge and halo. As our tools improve, our map becomes calmer and clearer. The galaxy does not change quickly, our understanding does. There is also a gentle concept called the habitable zone around stars. It is a region where a planet could have temperatures that allow liquid water depending on conditions. This does not guarantee life. It only suggests one ingredient might be possible. In the Milky Way, with so many stars, there may be many such zones. Some might be in quiet systems, far from energetic activity. Some might be in clusters where stars are close together. The galaxy offers many settings, like different rooms in a vast house. As you imagine these rooms, it helps to remember how calm the vastness is. Space is mostly empty. The distances between stars are huge. Even in crowded regions, stars are separated by trillions of kilometers. If you could travel through the disk, you would pass long stretches of darkness between points of light. The Milky Way is not a crowded city. It is more like a wide landscape at night, with distant lights scattered far apart. The quiet between them is part of the beauty. Some stars in the Milky Way are so bright that they shape the regions around them. They can blow strong winds that push gas outward. They can also end their lives in ways that return energy and material to space. But even then, the galaxy absorbs these events into its larger calm. The disk keeps rotating. Clouds keep drifting. New stars keep forming. Over long times, the Milky Way is steady in its rhythms. If you listen to the idea of rotation for a moment, you can picture the sun on its slow path. It carries Earth and the other planets along, like a small boat on a wide current. The current is the galaxy's orbit, moving at a steady pace through the disk. We do not feel this motion because everything around us shares it, yet it is always happening. Even as you rest, you are traveling through a grand, silent curve. Some people find comfort in scale, and some find it dizzying. If it feels too large, you can bring it back to something simple. The Milky Way is a home pattern in the sky, a familiar arch that rises and falls with the year. It is a reminder that we are part of a larger system without needing to solve it all at once. You do not need to hold the whole galaxy in your mind. You only need to let it be there, gently. In the distance, there are regions of the Milky Way that are hidden behind thick dust. But dust is not just an obstacle, it is also a building material. It helps molecules form, and it helps clouds cool. Without dust, star formation would be different. It also makes beautiful silhouettes against the star fields. In a calm way, dust is both veil and seed. It hides, and it helps create. The galaxy also has a bar-like structure in its central region, which is common in spiral galaxies. This bar can guide the flow of gas toward the inner areas. That inflowing gas can feed star formation near the center. It can also influence the overall spiral pattern. Bars are part of how galaxies rearrange themselves over time. Even on the largest scales, structure can shift slowly, like furniture moving in a quiet house. When we talk about the center, it is easy to imagine a single point, but the central region is extended and complex. It contains dense star fields, clouds of gas, and energetic activity. Much of it is hidden in visible light, so infrared images reveal a richer scene. The closer you look, the more layers appear. And still, it remains far enough away that it feels like a distant city at night, bright but unreachable. It is also worth remembering that the Milky Way is old. It began forming not long after the universe itself became old enough for stars and galaxies to form. The story of the Milky Way is fascinating. But to read the very first chapter of our cosmic history, we have to go back to the ultimate beginning, a moment of unimaginable creation known as the Big Bang. It is the deepest rest imaginable, a state of perfect stillness before the first movement of creation. Here, everything that will ever exist is held within a single point. This point is known as a singularity. It is smaller than an atom, smaller than a grain of sand, yet it contains all the matter and energy of the entire future universe. It is incredibly hot and incredibly dense, but it is not chaotic. It is unified. Every galaxy, every star, and every drop of water that will ever be is currently crushed together in a tight, warm embrace of unity. This tiny seed of the universe is suspended in a void that is not empty space, but nothingness. It is difficult for our minds to grasp, but there is no outside to this seed. Space itself is curled up tightly inside it. There is no up or down, no left or right. There is only the singular point, pulsing gently with a rhythm we cannot hear, waiting for the precise moment to unfold. Then, in a fraction of a second too small to measure, the expansion begins. It is not an explosion into existing space, but an expansion of space itself. Like a flower blooming in fast motion, the universe stretches outwards in all directions at once. This event is the Big Bang. It is not a loud bang, but a silent, majestic opening. The fabric of reality unrolls, creating room where there was no room before. This initial phase is called cosmic inflation. In less than a blink of an eye, the universe grows from the size of a proton to something vast and wide. It expands faster than the speed of light, carrying energy with it. It creates a smooth, even canvas for the cosmos. This rapid stretching smooths out any wrinkles or imperfections, leaving behind a universe that is uniform and balanced. As the inflation slows down, the energy begins to transform. The universe is now a hot, dense soup of particles. It is filled with a quark-gluon plasma, a state of matter so energetic that atoms cannot yet form. It is a fluid world, churning and flowing with intense heat. Imagine a thick, glowing fog. It is opaque and bright, filled with a light that cannot yet travel freely because it is constantly bumping into the density of the particles. This primitive universe is filled with quarks. These are the fundamental building blocks of matter. They dance and collide in the heat, constantly moving, never settling. They come in different types or flavors, pairing up and separating in a microscopic ballet. Alongside them are gluons, the particles that carry the strong force. They act as the glue, trying to bind the quarks together, but the heat is still too intense for any permanent bonds to hold. Despite the heat, the universe is already beginning to cool. As space expands, the energy is spread out over a larger area, causing the temperature to drop. It falls from trillions of degrees to billions. This cooling is the key to creation. Just as steam cools to become water, the energy of the Big Bang cools to become matter. It is a slow, steady condensation of reality. Gravity begins to emerge as a player in this cosmic game. At this stage, gravity is unified with the other fundamental forces. As the universe cools, these forces separate from one another, each taking on its own distinct role. It is like a choir separating into different harmonies. The electromagnetic force, the weak force, and the strong force all find their unique voices, setting the rules for how physics will work for the rest of eternity. We are now 1 second into the life of the universe. It seems like a short time, but in the scale of the cosmos, an entire epoch has passed. The universe is now cool enough for protons and neutrons to form. The quarks we saw earlier finally slow down enough to be caught by the gluons. They click together in groups of 3, forming the heavy cores of future atoms. These new protons are positively charged and the neutrons are neutral. They drift in the hot plasma, bumping into one another. For the first time, there is substance. There is something solid in the mist. We watch these tiny particles stabilize. They are the ancestors of every atom in your body right now. The hydrogen in the water you drink was born in this exact moment, 1 second after the beginning. But the universe is still too hot for electrons to join them. Electrons are tiny, energetic particles that zip around at incredible speeds. They refuse to be captured by the protons. They fly freely through the fog, creating a chaotic electric environment. Because of these free electrons, light is still trapped. Photons, the particles of light, bounce off the electrons like billiard balls. The universe is glowing, but it is a thick, impenetrable glow. This period is known as the photon epoch. If we were there, we would see nothing but a blinding white brilliance in every direction. There are no shadows, no dark corners, only absolute light. It is a bath of pure radiation. The energy is so high that matter and antimatter are constantly being created and destroyed, appearing and vanishing in flashes of energy. Slowly, the balance tips in favor of matter. For reasons that are still a mystery, slightly more matter is created than antimatter. When they cancel each other out, a tiny residue of matter remains, is less than has own. 2 is greater than. This leftover dust, this tiny fraction of surplus material, is what makes up all the stars and galaxies we see today. We are made of the leftovers of the Big Bang, the lucky survivors of the early chaos. We move forward in time, crossing the 3-minute mark. The universe has cooled to about 1 billion degrees. This is the temperature of the core of a star. It is now cool enough for the first atomic nuclei to fuse together. Protons and neutrons collide and stick, forming the nuclei of helium. This process is called nucleosynthesis. It is the first time chemistry becomes possible. For the next few minutes, the entire universe acts like a giant nuclear reactor. It churns out hydrogen and helium, the two lightest and most abundant elements. It also creates tiny traces of lithium. These 3 elements are the primary ingredients of the cosmos. Everything else, the carbon in our cells, the oxygen we breathe, the iron in the earth, will have to wait billions of years to be forged in the hearts of stars. But the foundation is being laid right now. After 20 minutes, the fusion stops. The temperature and density have dropped too low for the nuclei to continue merging. The great furnace of the Big Bang goes quiet. The composition of the universe is now set, roughly 75% hydrogen and 25% helium. This ratio will remain largely unchanged for eons, a chemical fingerprint of the creation event. Now, the universe enters a long period of waiting. It continues to expand, getting bigger and cooler with every passing year. The frantic energy of the first few minutes settles into a calm, steady drift. The plasma is still thick and foggy, trapping the light, but the violence has passed. The universe is simply breathing out, stretching its limbs into the void. We drift through this opaque plasma for thousands of years. There is nothing to see yet, only the glowing mist. But within this mist, sound waves are traveling. These are pressure waves rippling through the dense fluid of the early cosmos. They create areas of slightly higher density and slightly lower density. These tiny ripples are the seeds of future galaxies. Without these gentle sound waves, the universe would have remained a smooth, boring soup forever. Time flows forward. We travel through this dense fog for nearly 380,000 years. In the grand scale of the cosmos, this is just a brief pause, but for us, it feels like an eternity of waiting. The universe continues to expand, stretching the space between particles. As it stretches, it cools. The intense fire of the beginning is fading, dropping down to about 3,000 degrees Kelvin. We notice a change in the chaotic dance of the particles. The frenetic electrons, which have been zipping around at wild speeds, finally begin to tire. They lose their kinetic energy as the temperature drops. They slow down, moving lazily through the plasma. For the first time, the positively charged protons can reach out and capture these slow-moving electrons. It is a moment of cosmic union. The proton pulls the electron into orbit. They bind together, neutralizing their electric charges. This process is called recombination. One by one, billions upon billions of hydrogen and helium atoms are born. The chaotic soup of charged particles transforms into a sea of stable, neutral gas. As the atoms form, something miraculous happens to the light. For hundreds of thousands of years, photons have been trapped, bouncing off the free electrons like balls in a pinball machine. They could travel only inches before being scattered. The universe was a glowing, opaque fog. But now, with the electrons locked safely inside the atoms, the path is clear. Suddenly, the fog lifts. The obstacles vanish. The photons are released from their prison. For the first time in history, light can travel in a straight line. It streams outwards in every direction, filling the universe with a brilliant, blinding flash. It is the moment the universe becomes transparent. If we were there, we would see the white mist dissolve into a crystal-clear expanse. This ancient light does not disappear. It continues to travel, carrying the image of the newborn universe with it. It flies through the void for billions of years, passing future galaxies that do not yet exist. Even today, this light is still washing over us. It is known as the cosmic microwave background radiation. It is the afterglow of the Big Bang, a faint whisper of heat that touches every corner of the sky. But as we drift further in time, this brilliance begins to fade. The universe is expanding rapidly, and as space stretches, it stretches the light waves traveling through it. The bright, visible light is pulled like a rubber band, becoming longer and redder. Slowly, the light shifts from white to orange, then to deep red, and finally into the infrared. Eventually, the light stretches so much that it becomes invisible to the human eye. The universe plunges into darkness. The brilliance of the Big Bang has cooled and faded away, and there are no stars yet to replace it. We have entered an era known as the Cosmic Dark Ages. It is a time of profound silence and shadow. We drift through this dark ocean for millions of years. There is nothing to see. There are no planets, no suns, no galaxies. There is only gas. Enormous, formless clouds of hydrogen and helium drift in the void. They are cold and quiet. The temperature of the universe drops near to absolute zero. It is the deepest winter the cosmos has ever known. But in the darkness, something invisible is at work. Dark matter, the mysterious substance that makes up most of the universe's mass, is gathering. We cannot see it, but we can feel its effects. It acts as a gravitational scaffold, a skeleton for the visible universe. It clumps together, creating pockets of higher gravity in the emptiness. These invisible clumps begin to pull gently on the gas clouds. Gravity is the sculptor of the universe. It is a weak force, but it is patient. It pulls constantly, never resting, never letting go. Slowly, atom by atom, the hydrogen gas is drawn towards the dark matter. The clouds begin to swirl and condense. We float near one of these gathering clouds. It is colossal, stretching across light years of space. As the gas flows inward, the center of the cloud begins to grow dense. The atoms are packed tighter and tighter together. Friction begins to heat the gas up. After millions of years of cold, warmth returns to the universe. These dense pockets are the seeds of stars. They are called protostars. They are not yet shining. They are still incubating, wrapped in thick cocoons of dust. They are dark hearts beating in the void, growing heavier and hotter with every passing century. The universe is pregnant with potential, waiting for the first spark to ignite. Let us linger here in the Dark Ages for a moment. It is a peaceful time. There are no explosions, no collisions, only the slow, rhythmic flow of gas. The universe is like a sleeper breathing deeply, inhaling the hydrogen into its lungs. We feel the scale of this stillness. It spans hundreds of millions of years. It is a long, restful night before the cosmic dawn. we drift through the filaments of the cosmic web. This is the structure of the universe on the grandest scale. Strands of dark matter and gas connect the dense clumps like a vast, three-dimensional spiderweb. The voids between the strands are truly empty, growing larger as the universe expands. We float in one of these voids, looking at the distant threads of gas where the future galaxies will be born. Inside the protostars, the pressure is building. Gravity continues to squeeze the core. The temperature rises from hundreds of degrees to thousands, then to millions. The hydrogen atoms are being pushed so close together that they can no longer avoid each other. They are trembling on the edge of fusion, waiting for the critical threshold. Finally, about 400 million years after the Big Bang, the moment arrives. In the center of a dense cloud, the temperature hits 10 million degrees. The hydrogen atoms slam together with such force that they fuse into helium, releasing a burst of pure energy. A shockwave travels outwards through the cloud. A light flickers on in the dark. It is not a diffuse glow like the Big Bang, but a pinpoint of intense, focused brilliance. The first star has been born. It is massive, hundreds of times larger than our own sun, burning blue and hot. It is a beacon in the black, signaling the end of the Dark Ages. Soon, other lights turn on nearby. One by one, like streetlights illuminating a city at dusk, the stars ignite across the cosmic web. The darkness is punctured by clusters of new fire. This period is beautifully named the Cosmic Dawn. The universe is waking up. These first stars are known as population 3 stars. They are the ancestors of all light. They are pure, made only of hydrogen and helium. They live fast and burn bright, consuming their fuel with a voracious appetite. Their light floods the surrounding gas, heating it up and blowing away the remaining fog. They are clearing the space, carving out bubbles of transparency in the clouds. We watch as gravity pulls these new stars together. They do not like to be alone. They gather in families, swirling around a common center. These are the very first galaxies. They are small and messy compared to the majestic spirals we see today. They are irregular clumps of light, colliding and merging, dancing a chaotic waltz in the early universe. As these first stars die, they perform a crucial act. In their final moments, they explode as supernovae. These explosions are not destructive, they are creative. Inside their cores, they have forged new elements: carbon, oxygen, nitrogen. When they explode, they scatter these seeds of life into the void. They are dusting the universe with the potential for rocky planets and, eventually, living things. We linger here in the era of the first galaxies. The universe is no longer a smooth fog. It has become a vast, intricate structure known as the cosmic web. Strands of invisible dark matter stretch across the void like spider silk, millions of light years long. Along these filaments, gas flows like water in a river, feeding the growing galaxies at the intersections. It is the skeleton of the cosmos, a silent architecture holding everything together. We drift along one of these great filaments. It is a lonely, quiet road between the cities of light. The distances here are unimaginable. To travel from one galaxy to another would take millions of years, even at the speed of light. But in this story, we have time. We float through the intergalactic void, feeling the immense scale of the emptiness. It is not scary, it is spacious, it is room to breathe. In the center of these young galaxies, something powerful is waking up. Gravity has pulled so much matter together that it has punctured the fabric of space itself. A supermassive black hole has formed. These are not monsters eating the universe, they are the anchors. They sit quietly in the heart of the galaxy, their immense gravity holding the billions of stars in orbit. Like a shepherd watching over a flock, the black hole keeps the galaxy from flying apart. We dare to drift close to one of these giants. We cannot see the hole itself, for it allows no light to escape. We see only a perfect sphere of darkness, a shadow in the starfield. Around it, gas swirls in a slow, glowing disk, waiting to fall in. Time itself slows down near the edge. If we were to stay here, millions of years would pass in the rest of the universe in the blink of an eye. It is a place of eternal stillness. Moving away from the center, we enter a stellar nursery, or a nebula. This is the most beautiful place in the cosmos. It is a cloud of gas and dust stretching for light years, illuminated by the stars within. The colors are breathtaking. Deep reds from hydrogen, bright blues from oxygen, and soft greens from nitrogen. It looks like a watercolor painting suspended in the dark, frozen in slow motion. These clouds are the factories of the universe. Inside them, the alchemy of creation is taking place. The early universe had only hydrogen and helium, simple, light gases. But you cannot build a rocky planet like Earth out of gas. You cannot build a human body out of just helium. We need heavier things. We need carbon for our cells, calcium for our bones, and iron for our blood. These elements do not exist yet. They must be forged. We watch an aging red giant star. It has burned for billions of years, and now it is swelling up, turning a deep, angry orange. Inside its core, the pressure is immense. It is crushing atoms together, fusing helium into carbon and carbon into oxygen. It is a cosmic kitchen, cooking up the ingredients of life. The star is sacrificing itself to create something new. When the red giant finally dies, it does not vanish. It gently puffs its outer layers into space. We watch the atmosphere of the star drift away, forming a ring of glowing gas. This is a planetary nebula. The carbon and oxygen it created are now free. They drift out into the galaxy, mixing with the dust clouds. These are the seeds of future worlds. Elsewhere, a much larger star reaches the end of its life. This is a supergiant. Its collapse is sudden and violent, a supernova. For a few weeks, it shines brighter than an entire galaxy. But in that explosion, a miracle happens. The heat is so intense that it forges the heaviest metals: gold, silver, platinum, uranium. Every ring of gold on a human finger was made in this exact moment. The explosion scatters this gold dust across the universe. It travels for eons, riding the shock waves of the blast, until it eventually settles in a quiet corner of space. We realize that the universe is a giant recycling system. Nothing is ever lost. The death of a star becomes the birth of a planet. The dust of the past becomes the body of the future. We drift through this enriched dust. It is no longer just gas. It contains tiny grains of silicate and ice. It sparkles in the starlight. These grains are sticky. When they bump into each other, they hold on. This simple act of sticking together is the first step in building a world. Time flows differently here. We watch galaxies collide. It sounds violent, but in reality, it is a ghostly dance. The stars are so far apart that they rarely hit each other. Instead, the two galaxies pass through one another, their shapes twisting and pulling. Over hundreds of millions of years, they merge into one larger, grander galaxy. It is a slow, graceful waltz of light and gravity. The universe is getting richer. With every generation of stars that lives and dies, the clouds become heavier with metals. The metallicity of the cosmos increases. The universe is preparing itself. It is laying the groundwork for complex rocky worlds. It is waiting for the right moment, the right place to build a home. We see a comet drifting alone in the dark. It is a dirty snowball, a relic from the dawn of time. It tumbles slowly, end over end. It is completely silent. On its surface, ice sublimates into gas, creating a long, faint tail that trails behind it for millions of miles. It is a traveler with no destination, a silent witness to the history of the deep. We look around at the sheer variety of the cosmos. There are pulsars, dead stars that spin hundreds of times a second, sending out beams of radio waves like a lighthouse. There are brown dwarfs, failed stars that were too small to ignite, glowing dimly with heat but no light. There are rogue planets, worlds that were kicked out of their solar systems, wandering alone in the eternal night, frozen and dark. They are all part of the family, the successful stars and the failed ones, the bright lights and the dark wanderers. The silence here is profound. It is not an empty silence, but a heavy, pregnant silence. It is the silence of a library filled with unread books. The information is there, written in the light of the stars, waiting to be understood. We let ourselves float in this library of light. We have nowhere to be, no deadlines to meet. The universe is in no rush, and neither are we. We feel the temperature of the deep space. It is cold, just a few degrees above absolute zero, but it is a preserving cold. It keeps the history of the universe frozen in time. The light from the first stars is still traveling here. The ripples from the first black holes are still passing through. In space, nothing truly vanishes. As we drift, we begin to approach a familiar shape. In the distance, a large spiral galaxy is turning. It has beautiful arms of blue stars and pink nebulas. It has a bright, yellow-white core. This is the Milky Way in its youth. It has finished its chaotic mergers. It has settled down into a stable, flat disk. We move towards it. We are looking for a specific cloud, a cloud that is rich in the gold and carbon and oxygen we just saw being created. We are looking for the birthplace of the Sunday. We watch as the universe begins to weave structure out of chaos. Gravity continues its endless work, pulling billions of these new stars together into massive swirling islands of light. These are the galaxies. They come in many shapes: ellipticals that look like fuzzy balls of wool, and irregulars that look like splattered paint. But the most beautiful of all are the spirals, spinning slowly in the dark like grand cosmic pinwheels. Among these billions of galaxies, one specific spiral begins to take shape. It is the Milky Way, our home. It starts as a smaller cluster, pulling in gas and merging with other small galaxies over billions of years. It grows into a magnificent disk of stars, 100,000 light-years across. It spins with a majestic slowness, taking 250 million years to complete a single rotation. We drift into the outskirts of this great spiral city. We are heading for a quiet neighborhood known as the Orion Arm. It is located about 2/3 of the way out from the frantic, crowded center of the galaxy. Here, about 4.5 billion years ago, there is no Earth and no Sunday. There is only a giant, cold cloud of molecular gas and dust floating in the silence. This cloud is a stellar nursery. It is filled with the ashes of dead stars that lived and died long ago. It contains hydrogen and helium, but also carbon, silicon, and iron, the dust of previous generations. It hangs there, beautiful and still, shimmering with the potential of 1,000 worlds. Then, a ripple passes through the cloud. Perhaps it is the shockwave from a distant supernova, a dying star sending a final push to create new life. The ripple disturbs the balance of the cloud. Gravity takes hold of the dust. The cloud begins to collapse inward, spinning faster and faster, like a figure skater pulling in her arms. In the center of this spinning disk, the pressure grows immense. Matter is crushed together until it ignites. A new star is born. This is our Sunday. In its youth, it is violent and bright, blasting out waves of solar wind. But soon, it settles into a steady, yellow burn. It is a main sequence star, a stable heart for a future solar system. But the Sun is not alone. Around the newborn star, a disk of leftover dust and gas remains. This is the protoplanetary disk. It looks like a glowing halo surrounding the young Sun. This dust is not waste. It is the building material for everything we know. We watch as tiny grains of dust collide and stick together, held by electrostatic forces. It is a gentle process at first. Dust becomes pebbles. Pebbles become rocks. Rocks become boulders. Over millions of years, these rocks smash into each other, merging to form planetesimals. They are the seeds of planets. Some grow large enough to have their own gravity, sweeping up everything in their path, clearing their lanes in the disk. In the warm inner region, close to the Sun, the rocky planets are born. Mercury, Venus, Mars, and Earth. We focus our attention on the third rock from the Sunday. 4.5 billion years ago, the Earth looks nothing like the blue marble we know today. It is a ball of molten fire, a magma ocean glowing red in the night. There is no solid ground yet, only a churning sea of lava. The planet is constantly bombarded by asteroids, adding more heat and mass to the growing world. It is a chaotic, fiery beginning. But slowly, the bombardment eases. The heat begins to radiate out into space. The surface starts to cool, forming a thin, fragile crust of black rock floating on the magma. Just as the Earth begins to stabilize, a massive event occurs. A planet the size of Mars, which scientists call Theia, is on a collision course. It crashes into the young Earth, but it is not an end. It is a merger. The impact sends a massive cloud of debris into orbit. The Earth survives, now larger and spinning faster. We watch the debris ring circling the Earth. It looks like the rings of Saturn, a band of hot rock and dust. Over just a few thousand years, gravity gathers this debris together. It clumps into a single large sphere. The moon is born. It looms huge in the ancient sky, much closer to Earth than it is today, a silent guardian watching over the cooling world. The moon begins its long dance with Earth. Its gravity tugs at the planet, creating the first tides in the molten rock. This interaction stabilizes the Earth's wobble. Without the moon, our planet would tilt wildly, causing chaotic climate swings. The moon becomes the anchor, keeping the Earth steady and creating the seasons we will one day know. Time passes, and the Earth cools further. Steam escapes from volcanoes, forming a thick atmosphere of water vapor and carbon dioxide. The sky is heavy and grey, hiding the sun. As the planet cools below the boiling point of water, the clouds open up. The first rain begins to fall. It is not a gentle shower. It is a deluge that lasts for millions of years. The water pours down onto the black rocks, filling the basins and the lowlands. Comets, dirty snowballs from the outer solar system, crash into the planet, bringing even more water and ice. They are the cosmic delivery trucks of the oceans. Slowly, the magma turns to stone, and the stone is covered by water. The first primitive ocean is formed. It is green and rich in iron, covering almost the entire planet. Tiny volcanic islands poke through the surface, the only land in a water world. The rage of the early solar system has quieted down. The planets have settled into their stable orbits, moving like clockwork around the Sunday. We drift over this ancient, quiet ocean. The atmosphere is still thick and lacks oxygen, but the stage is set. In the deep, warm waters, near hydrothermal vents, simple chemicals are beginning to mix. They are learning to copy themselves. The long, slow journey of life is about to begin. We look up from the surface of this young water world. The sky has cleared. The stars are shining down on the reflection of the waves. It is a peaceful scene, a moment of equilibrium after billions of years of violence. The Earth is ready. It is waiting. We pull back now, leaving the surface of the Earth. We rise up, past the clouds, past the moon, until we can see the whole solar system spinning in the dark. It is a tiny oasis of order in the vast wilderness of the Milky Way. We realize that we are made of this history. The hydrogen in the water was made in the Big Bang. The iron in the Earth's core was forged in a supernova. The gold in our jewelry was created in the collision of neutron stars. We are not separate from the universe. We are the universe, cooled down and awakened, looking back at itself. We are now floating in the present day, 14 billion years after that first silent second. The universe has grown from a single point into an expanse so vast that the human mind cannot truly comprehend it. It stretches for 93 billion light-years, a canvas of infinite depth. It is still expanding. The energy of the Big Bang has not stopped. It has simply quieted down, pushing the galaxies apart gently but firmly. We drift through the space between the galaxies. This is the true face of the universe. It is not crowded or chaotic. It is mostly empty, silent space. The galaxies are just tiny islands of light floating in a vast, dark ocean. The distance between them is growing every moment. The universe is taking a deep, slow breath that never ends, inhaling darkness and exhaling space. In this vast emptiness, there is a profound sense of peace. There is no friction here. A planet or a star drifting through space will continue to drift forever, never slowing down, never stopping. It is the ultimate state of rest. We imagine ourselves drifting with that same lack of resistance, carried by the momentum of creation without having to lift a finger. We look towards the future of the cosmos. Astronomers call it the Big Freeze. It sounds cold, but in a way, it is comforting. It means the universe is slowly moving towards a state of perfect equilibrium. Over trillions of years, the stars will eventually burn out. The frantic energy of the beginning will finally be spent. The universe will become a quiet, dark place, resting after its long burst of activity. It is a slow fade into sleep on a cosmic scale. Just as we wind down at the end of a long day, the universe is winding down at the end of its long life. It is not an ending to be feared, but a natural settling of dust. Entropy is simply the universe's way of relaxing. It is the natural tendency of things to let go of their energy, to stop struggling, and to come to rest. We think back to the singular point where we started. We were all there. Every atom in your body was packed into that tiny seed. We have been on this journey together since the very first moment of time. You are not a stranger to this universe. You are a part of it. You are the universe experiencing itself, its own history, its own silence, and its own sleep. The gravity that holds the Earth in orbit is the same gravity that holds you to your bed. When the universe burst into existence during the Big Bang, it didn't just create space, time, and matter. It unleashed the fundamental forces of nature. The most familiar of these is gravity. It is the invisible hand that gently holds you to your bed every night, keeping you safely tethered to the earth. But this everyday force plays a much grander, more powerful role across the cosmos. Long before it was anchoring you as you sleep, that exact same gravitational pull was hard at work in the dark voids of space, patiently drawing together colossal clouds of gas and ancient stardust to craft the sun, the planets, and the intricate dance of our very own solar system. It is a colossal sphere of glowing plasma, a perfect circle of light that has been burning for 4.5 billion years. It is the steady heartbeat of our solar system, constant and reliable. It holds 99.8% of all the mass in the entire solar system. Everything else, Jupiter, Earth, the comets, is just leftover dust compared to this giant. The gravity of the sun is what keeps us safe. It is an invisible tether swinging the planets in their wide, predictable orbits. Just as the sun holds the Earth, let the bed beneath you hold you now. You do not need to hold yourself up. You are anchored and supported by forces much larger than yourself. We drift closer, feeling the warmth, but not the burn. The surface of the sun, the photosphere, is a churning sea of golden fire. Here, granules of hot plasma rise and fall like bubbles in a slow-motion pot of honey. Each of these bubbles is the size of a country like France. They rise, cool down, and sink back into the depths, a rhythmic breathing of the star itself. Sometimes, dark spots appear on this golden face. These are sunspots, areas that are slightly cooler than the surroundings. They look small to us, but many are larger than the entire Earth. They are calm islands in the stream of energy, governed by twisting magnetic fields. Even in the heart of the fire, there are pockets of cooler quiet. From the sun's surface, a constant breeze blows outwards. This is the solar wind, a stream of charged particles that washes over the planets. It travels at 1,000,000 miles per hour, creating a bubble around the solar system called the heliosphere. It protects us from high-energy galactic dust, acting like a cosmic shield. We are living inside a protective bubble, sheltered from the deeper, wilder universe. Deep inside the sun, the process of fusion is taking place. Hydrogen atoms are being crushed together to form helium, releasing pure energy. It takes a photon of light thousands of years to travel from the core to the surface. The sunlight that touched your face today began its journey before human history even started. It is ancient light, arriving just in time to warm the Earth. We turn our back to the brilliance and look at the first planet, Mercury. It is a small rocky world, not much larger than our own moon. Because it is so close to the sun, it is stripped bare. There is no atmosphere to soften the light. The sky here is always black, even during the day. If you stood on Mercury, the sun would look 3 times larger than it does on Earth, a massive spotlight in the dark. Mercury is a world of silence and scars. Its surface is covered in craters, memories of ancient collisions that happened eons ago. Since there is no wind and no rain, these craters never erode. A footprint left here would last for millions of years. It is a place of absolute stillness where nothing changes and nothing moves. One of the largest features is the Calories Basin. It is a gigantic impact crater, so large that the shockwave traveled through the entire planet and crumpled the ground on the exact opposite side. But that violence is long gone. Now, it is just a vast, dusty plain of dry rock, baking in the heat. The temperature swings here are the most extreme in the solar system. During the day, the rock is hot enough to melt lead, but Mercury spins incredibly slowly. One day on Mercury lasts for 59 Earth days. This means the night is long and freezing. Without a blanket of air to trap the heat, the temperature plummets rapidly when the sun sets, dropping to -180 degrees. Deep in the craters at the poles, shadows hide secrets. The floors of these craters have never seen sunlight. In this eternal darkness, radar has detected ice. It is a beautiful paradox. Water ice existing on the closest planet to the fire. It reminds us that even in the harshest places, there are hidden pockets of cool relief. Mercury has a tail, like a comet. The solar wind blasts atoms of sodium off the surface, creating a long, invisible tail that trails behind the planet. It is a ghost of an atmosphere, drifting silently into the void. It is a reminder that you can leave things behind, letting them drift away like dust in the wind. We watch the little planet race around its orbit. It is the fastest of all the planets, named after the swift messenger god. It completes a circle every 88 days. It is always in a hurry, so you don't have to be. You can watch it spin from a distance, enjoying your own slowness, your own stillness. We drift away from the intense heat of the inner solar system, moving outwards to the second planet, Venus. From a distance, it is the most beautiful object in the sky, shining with a brilliant, creamy white light. It is often called the morning star or the evening star, a jewel that has guided travelers for thousands of years. It looks peaceful and inviting, a twin to our own Earth in size and weight. But this beauty hides a secret beneath its veil. Venus is wrapped in a thick, unbroken layer of clouds. These clouds are not made of water, but of sulfuric acid, and they reflect almost all the sunlight that hits them. This reflection is what makes the planet shine so brightly in our night sky. The atmosphere here is incredibly dense, 90 times heavier than the air on Earth. Standing on the surface would feel like being a kilometer deep under the ocean, wrapped in a heavy, crushing embrace. Beneath these clouds, the heat is trapped. Even though Venus is farther from the Sun than Mercury, it is actually hotter. The thick atmosphere acts like a greenhouse, locking the warmth inside forever. It is a world of eternal, sweltering heat, where the rocks themselves glow faintly in the dark. But you are safe here, observing from the cool silence of space, far above the heavy air. Venus spins in a unique way. While most planets spin counterclockwise, Venus spins clockwise, moving in the opposite direction to its sisters. It is a rebel in the dark. It also spins with agonizing slowness. A single day on Venus lasts longer than a year on Venus. The sun rises in the west and sets in the east, taking months to cross the sky. There is no rush on this planet. The winds in the upper atmosphere might race at hurricane speeds, but down near the surface, the air is sluggish and slow. It moves like a thick liquid, drifting gently through mountains and valleys that have been shaped by thousands of ancient volcanoes. It is a landscape of slow, heavy change. We leave the white glare of Venus and turn towards the third rock from the Sunday. As it comes into view, we feel a deep sense of recognition. This is the blue marble. This is home. It hangs in the void like a fragile ornament, swirled with white clouds and vast oceans of deep indigo. It is the only place we know of where life exists, a tiny oasis in the infinite desert of space. From up here, there are no borders. We see only the brown and green of the continents and the endless blue of the water. The Earth is covered in 70% water, a liquid mirror reflecting the sun. Just looking at this blue color calms the mind. It reminds us of cool lakes, of rain, of the ocean waves that have a rhythm just like your breathing. The Earth sits in the Goldilocks zone. It is not too close to the fire and not too far in the cold. It is just right. This perfect balance allows water to flow and life to flourish. You are part of this balance. You are exactly where you need to be, held safely by the gravity of a kind and habitable world. Surrounding our planet is a thin, glowing line of blue. This is the atmosphere, a delicate shell of nitrogen and oxygen that protects us from the vacuum. It is thinner than the skin of an apple compared to the size of the Earth. Yet, this thin layer stops the meteors, scatters the sunlight to make the sky blue, and gives us the air we breathe. Take a deep breath now and appreciate that air filling your lungs. Invisible lines of magnetism loop out from the poles. The Earth acts like a giant magnet, creating a shield called the magnetosphere. It deflects the solar wind we saw earlier. When the solar wind hits this shield near the poles, it glows, creating the auroras. Curtains of green and purple light dance silently in the upper atmosphere, a cosmic light show just for us. Orbiting our world is a faithful companion, the Moon. It is unusually large for a moon, a quarter the size of the Earth itself. It is a rocky, dusty world, grey and silent against the black sky. It is tidally locked to us, which means it spins at the exact same speed that it orbits. Because of this, it always shows us the same face. The man in the moon has been watching over the Earth for billions of years. The moon is a stabilizer. Its gravity pulls gently on the Earth, creating the tides. It drags the oceans back and forth in a slow, rhythmic cycle. High tide, low tide, in and out. Without the moon, the Earth would wobble chaotically on its axis. The moon keeps our seasons steady. It is an anchor, keeping our world balanced and calm. We look at the surface of the moon. The dark patches are called maria, the Latin word for seas. Ancient astronomers thought they were oceans, but they are actually vast plains of solidified lava. They are smooth and flat, resting in the silence of a vacuum. There is no sound on the moon. No wind rustles the dust. It is a place of perfect peace. We push gently away from the Earth and moon, floating deeper into the dark. Ahead of us hangs a ruddy, amber-colored point of light. As we approach, it grows into a sphere of rust and rock. This is Mars, the red planet. The color comes from iron oxide simple rust that covers the entire surface. It is a world that has literally rusted over time, like an old iron gate left in the rain for eons. Mars is cold and quiet. It is a desert world, much colder than Earth because it is farther from the sun's warmth. The atmosphere here is very thin, made mostly of carbon dioxide. If you stood on the surface, the sky would not be blue, but a soft, dusty pink or butterscotch color during the day. At sunset, something strange happens. Because of the fine dust in the air, the sunsets on Mars are blue. Imagine standing on a red dune, watching a small blue sun dip below the horizon. It is a reversal of everything we know, a peaceful alien twilight. Two small moons orbit this world. They are called Phobos and Deimos, names that mean fear and panic, but they do not look scary. They look like lumpy potatoes, captured asteroids that drifted too close and got caught in Mars's gravity. They are tiny compared to our moon. Phobos is so close to Mars that it races across the sky 3 times a day, a fast-moving shadow on the red ground. Mars is a planet of forgotten giants. We drift over the equator and see a colossal scar cutting across the planet's face. This is Valles Marineris, a canyon system that makes the Grand Canyon look like a scratch. It is 4,000 kilometers long. If you placed it on Earth, it would stretch from New York to California. It is a vast, silent valley where the wind howls through empty corridors of rock. To the west stands Olympus Mons. It is the largest volcano in the entire solar system. It is 3 times the height of Mount Everest. The base of this volcano is so wide that it would cover the entire country of France. Its slope is so gentle that if you were climbing it, you wouldn't even know you were on a mountain. You would just be walking uphill towards the stars forever. There is no lava flowing now. Olympus Mons has been asleep for millions of years. The fires inside Mars have gone out. It is a geological fossil, a monument to a time when the planet was young and active. Now it just sits there, collecting dust, perfectly still. We look closely at the ground. We see winding channels and dry riverbeds. Billions of years ago, water flowed here. There were lakes, rivers, perhaps even an ocean. But the atmosphere thinned, and the water vanished into space or froze underground. Mars is a world that dried up, holding the memory of water in its dry stones. Sometimes, a dust storm covers the planet. These storms can grow to cover the entire globe, wrapping Mars in a blanket of haze. But because the air is so thin, the storm doesn't knock things over. It is more like a fine, billowing fog of powder settling gently over everything like snow. We leave the red deserts behind and drift further out. We are entering a strange region of space between Mars and Jupiter. This is the main asteroid belt. In movies, this is often shown as a crowded, dangerous field of colliding rocks. But space is vast, and the reality is much more peaceful. The asteroids are millions of kilometers apart. If you were standing on one asteroid, you probably wouldn't even be able to see the next one with your naked eye. It would just be another star in the distance. Drifting here is not dangerous. It is lonely and spacious. You have plenty of room to breathe, plenty of room to float without bumping into anything. These are the leftovers of the solar system. They are the building blocks that never became a planet. Jupiter's massive gravity prevented them from clumping together. So they remain as they were at the beginning, silent fragments of rock, metal, and ice, unchanged for 4 billion years. Some are large, like dwarf planets. Ceres is the queen of the belt, a spherical world with mysterious bright spots of salt on its surface. It might even have a hidden ocean of water ice beneath its crust. Others are small, oddly shaped boulders tumbling slowly in the dark. They rotate with a lazy rhythm. Some take hours to spin, others take days. They are in no rush. They are simply following the path laid out for them by gravity. There is a comfort in this predictability. Just like these stones, you are following a natural rhythm towards sleep. You don't need to steer. You just need to let go and drift. Beyond the floating stones of the asteroid belt, the space opens up again. We drift through millions of miles of empty, silent dark. Ahead of us, a monster begins to take shape. It is Jupiter, the king of planets. It is so massive that all the other planets could fit inside it with room to spare. It does not have a solid surface to stand on. Jupiter is made almost entirely of gas and liquid, swirled into bands of cream, rust, and brown. These bands are actually clouds stretching all the way around the planet, driven by winds that blow at hundreds of miles per hour. But from our distance, they look painted on, smooth and still. Dominating the southern hemisphere is the Great Red Spot. It is a storm that has been raging for at least 300 years. It is wide enough to swallow the Earth whole. We watch it spinning slowly, a giant crimson eye that never blinks. Even the most violent storm looks peaceful from far enough away. Jupiter acts as a guardian for the Earth. Its immense gravity pulls in comets and asteroids that might otherwise head towards us. It is the solar system's vacuum cleaner. It has taken many hits over the eons so that we don't have to. You can feel safe knowing this giant is out there, quietly catching the debris in the dark. Surrounding the king are his many moons. There are roughly 95 of them, like a miniature solar system of their own. The 4 largest were seen by Galileo 400 years ago. Ganymede is the largest moon in the solar system, bigger even than the planet Mercury. It is a world of ice and rock, silently circling its master. Europa is the most mysterious. Its surface is cracked ice, white and smooth. Beneath that frozen shell lies a vast, deep ocean of liquid water. It contains twice as much water as all of Earth's oceans combined. It is a hidden world, sealed away in the dark, waiting to be discovered. We leave the king and drift further out to the jewel of the solar system. Saturn appears, golden and pale. It is the second largest planet, but it is incredibly light. It is the only planet less dense than water. If you had a bathtub big enough, Saturn would float in it like a rubber duck. But it is the rings that capture our eyes. They are the most spectacular sight in the heavens. Thousands of individual ringlets stretch out into space, thin and wide. They are not solid. They are made of billions of pieces of water ice, ranging from the size of a grain of sand to the size of a house. The ice shines in the sunlight. It reflects the distant sun like a halo of diamonds. Imagine floating just above the rings, watching the particles drift gently in their lanes. There is no sound here, just the silent, shimmering dance of ice and light. It is a hypnotic motion, round and round, endless and perfect. Sometimes, tiny moons carve paths through the rings. These are called shepherd moons. Their gravity keeps the rings neat and tidy, herding the ice particles back into place. Even in this vastness, there is order. There are rules. The universe keeps itself organized without any effort from you. At Saturn's North Pole, there is a strange hexagon. It is a 6-sided jet stream, a perfect geometric shape made of clouds. It rotates at the exact same speed as the planet's interior. It is a reminder that nature loves patterns, from the smallest snowflake to the largest storm. We look at Titan, Saturn's largest moon. It is the only moon with a thick, hazy orange atmosphere. Beneath those clouds are lakes and seas, but not of water. They are lakes of liquid methane and ethane. It rains fuel on Titan. It is a familiar cycle of rain and rivers, but on a world that is alien and frozen. The distance from the sun is growing. The light is getting dimmer here. The sun is no longer a blinding disk, but a very bright star. The warmth is fading. We are entering the realm of the deep freeze, where everything moves slower. We linger here for a moment in the shadow of the giants. Before we leave the realm of Jupiter and Saturn, there are hidden worlds we must visit, tiny spheres of ice and fire orbiting silently in the dark. We turn our gaze to Jupiter's innermost moon, Io. It is a world of vivid color, yellow, orange, and red, painted by sulfur. It looks like a giant pizza hanging in the black sky. It is the most volcanically active body in the solar system, but from our safe distance, we do not hear the roar. We only see the silent plumes of smoke, rising hundreds of kilometers into space, freezing instantly into colorful snow. Io is caught in a gravitational dance. Jupiter pulls it one way, and the other moons pull it the other way. This constant tugging heats up the moon's core, keeping it molten. It is a world that is constantly reshaping itself, erasing its own craters. It is a reminder that even in the cold of space, there is heat, there is change, there is life in the rock. Drifting further out, we pass the battered face of Callisto. It is the oldest landscape in the solar system. Its surface is completely covered in craters, layer upon layer, a record of every collision for 4 billion years. Callisto is dead and quiet. It has not changed since the beginning of time. It is a fossil of the early universe, floating peacefully in the dark. Between these moons, space is not empty. Charged particles from Jupiter's magnetic field flow like invisible rivers. We float through them, feeling nothing but a sense of electric calm. You are safe here, drifting like a ghost through the magnetic web of the king. We move outwards again, crossing the vast gap to Saturn's family. Hidden among the brilliant rings lies a tiny, glittering moon called Enceladus. It is small enough to fit inside the North Sea. It is the whitest object in the solar system, covered in fresh, clean ice. It reflects the sunlight like a mirror, shining with a pure, innocent light. But Enceladus has a secret. At its south pole, great geysers of water vapor and ice crystals shoot out into space. They are like fountains in the dark. These geysers are fed by a warm, salty ocean hidden beneath the ice, a global sea that has never seen the sun, yet stays liquid because of Saturn's gravity. The ice crystals from Enceladus do not just vanish. They drift out to form one of Saturn's rings, the E-ring. The moon is quietly creating its own path, painting a circle of ice around its planet. Imagine floating through this mist of ice. It is a soft, silent blizzard in the vacuum. The crystals sparkle around you, millions of tiny diamonds dancing in the silence. We drift past Mimas. It has one giant crater that makes it look like a watching eye, yet it is just a ball of ice, frozen and still. And further out, the strange moon Iapetus. It is two-toned. One side is white as snow, the other black as charcoal. It has a ridge of mountains running exactly along its equator, like a walnut. It spins alone, far from the others, a solitary traveler in the outer dark. We leave Saturn behind now. The journey to the next planet, Uranus, is incredibly long. It is not a short hop. It is a voyage across a deep, wide ocean of nothingness. The distance between Saturn and Uranus is equal to the distance from the Sun to Saturn. We have to cross the solar system all over again just to reach the next stop. This is the true void. Here, the Sun is just a very bright star. The light is weak, the shadows are long. There is no sound, there is no wind, there is only the feeling of endless open space. You have so much room here. The crowding of the inner planets is gone. The busy energy of the asteroid belt is gone. There is just you and the silence. It wraps around you like a heavy, soft blanket. There is nothing you need to do, nothing you need to solve. In this gap, we find the centaurs. These are strange objects, half asteroid and half comet. They drift in unstable orbits, wandering between the giant planets. One of them, Chariklo, even has its own tiny rings, a small rock with a halo, mimicking the giants, spinning quietly in the middle of nowhere. We feel the cold deepening. The temperature drops with every million miles we cross, but it is not a biting cold. It is a preserving cold. It slows everything down. Atoms vibrate slower here. Time seems to stretch out, becoming long and thin. Your breathing slows down to match the journey. Inhale and exhale, drifting across the gap. You are a traveler of the void, weightless and unburdened. The destination is far away, but the journey itself is the destination. We see comets sleeping here. Far from the sun, they do not have tails. They are just dark, dirty snowballs, waiting for their turn to fall inward. They are the ancient seeds of the solar system, holding water and dust from the very beginning. They are sleeping capsules of history. As we finally approach the realm of the ice giants, the light changes. It becomes blue and ghostly. We are entering the outer suburbs of our home. The neighborhood is quiet here. The houses are far apart. It is the perfect place to rest, a place where nothing happens quickly, a place of eternal frozen peace. We drift further into the twilight, leaving the golden glow of Saturn behind. Ahead lies the seventh planet, Uranus. It is a pale blue-green sphere, ghostly and almost featureless. It gets its color from methane in the atmosphere, which absorbs red light and reflects the cold blues back into space. It looks like a frozen aquamarine gem hanging in the dark. Uranus is the sleeping planet. While all other planets spin like spinning tops, Uranus rolls on its side. Its axis is tilted 98 degrees. It orbits the Sun like a ball rolling across a smooth floor. Because of this extreme tilt, its poles face the Sun directly for 42 years at a time. It is the coldest planetary atmosphere in the solar system. Temperatures here drop to -224 degrees Celsius. The heat of the Sun is just a memory here. It is a world of ice giants, made not of gas, but of heavy, slushy fluids of water, ammonia, and methane. It is a slow, churning ocean with no bottom. Finally, we reach the last true planet, Neptune. It is a deep, vivid azure blue, darker and richer than Uranus. It is the windiest world we know. Supersonic winds whip through the clouds at 2,000 kilometers per hour, faster than the speed of sound. Yet, from here, it looks perfectly still, a silent blue marble in the abyss. Orbiting this windy world is Triton. It is a moon that moves backwards, in retrograde, opposite to the spin of the planet. Triton is a captured soul, likely plucked from deep space by Neptune's gravity long ago. It has geysers that shoot liquid nitrogen 8 kilometers into the thin atmosphere, freezing instantly into snow. Beyond Neptune, the planets end. We enter the Kuiper Belt, the twilight zone of the solar system. Here, thousands of icy worlds drift in the shadows. They are the frozen debris from the solar system's birth, preserved in a cosmic freezer for 4 billion years. The most famous of these is Pluto. It is smaller than our moon, a tiny world of rock and ice, but it has a heart. On its surface is a vast glacier of nitrogen ice shaped exactly like a heart. It is called Sputnik Planitia. This heart is alive. The nitrogen ice slowly churns and flows like a glacier on Earth, erasing craters and smoothing the surface. Even at the edge of the solar system, where the sun is just a bright star, there is activity. There is a slow, beating heart in the cold. We drift past Pluto towards the very edge. This is the heliosphere, the bubble where the sun's influence finally fades away. Beyond this boundary lies interstellar space, the void between the stars. It is the beginning of the true unknown. The Voyager space probes are out here. Launched in the 1970s, they are still traveling, carrying gold records with sounds of Earth into the silence. They are the furthest human-made objects in existence, silent ambassadors floating forever away from home. We look back towards the center. The sun is now just a point of light, barely distinguishable from the other stars. The Earth is invisible, lost in the glare. All the noise, all the hurry, all the worry is billions of miles away. It cannot reach you here. You are floating at the edge of the night. The stillness here is absolute. There is no wind. There is no sound. There is only the slow, majestic clockwork of gravity, turning the wheels of the heavens. As we journey to the very edge of our solar system, the lively, intricate dance of the planets finally fades into profound stillness. Out here, in the farthest reaches, there is absolute silence. No sound travels through the vacuum, and nothing seems to move across the icy, empty void. It feels like the universe has simply stopped. But this tranquil darkness is incredibly deceiving. Far beyond the peaceful, frozen borders of our planetary home, lurking unseen in the pitch-black depths of the wider galaxy, exist cosmic phenomena of unimaginable power and mystery. Regions where the very fabric of space and time is warped beyond recognition, and gravity becomes a trap so intense that not even light itself can break free. We are now entering the realm of black holes. We will journey to the places where gravity becomes so strong it conquers light itself. We are going to visit the black holes. But do not be afraid. In our story tonight, they are not monsters. They are simply the quietest places in the universe. They are the deep pools of silence where the cosmos goes to rest. To understand the shadow, we must first understand the light. A black hole does not start as a hole. It starts as a star, brilliant and alive. We drift towards a massive nebula, a cloud of gas floating in the void. This is a stellar nursery. It is a place of soft colors, pinks, violets, and deep blues. Here, gravity acts like a sculptor. It gently pulls the dust particles closer together. Slowly, over millions of years, the cloud begins to spin. It grows denser, it grows warmer. It is a slow, patient process, like weaving a blanket. Finally, in the center of the cloud, a spark ignites. A star is born. It shines with a fierce, blue-white light. It is massive, far larger than our own Sunday. It is a king among stars, ruling over its sector of space with immense power. For millions of years, it lives in a perfect balance. Gravity tries to crush it inward, while the energy of its burning core pushes outward. It is a standoff, a cosmic stalemate. The star hangs in the void, round and perfect. Just like you found a balance in your bed tonight, suspended between being awake and being asleep. The star is stable, it is calm. But even stars have a lifespan. Even stars eventually run out of fuel. And when a massive star gets tired, it prepares for a magnificent transformation. We move closer to this giant star. We can feel its immense energy, a humming vibration in the fabric of space. Deep inside the core, a miraculous process is happening. It is a cosmic alchemy. Hydrogen atoms are smashing together, fusing to create helium. This fusion releases pure energy. It is the heartbeat of the star. For us, a fire needs wood to burn. But a star burns its own body. It transforms itself, element by element. Over millions of years, the core gets hotter and tighter. It starts creating heavier things. Carbon, neon, oxygen. The very ingredients that make up the rocks, the oceans, and even your own bones are being forged right here in this stellar furnace. We are all made of stardust. But there is a limit. The star begins to create iron. Iron is the ash of the cosmos. It is heavy. It is stubborn. It absorbs energy instead of creating it. The engine begins to stutter. The outward pressure that held the star up for so long starts to fade. Gravity, which has been waiting patiently for millions of years, sees its chance. The balance is broken. Suddenly, the silence of the void is interrupted. In a fraction of a second faster than you can blink, the star collapses. The iron core, the size of a planet, crumbles inward. It shrinks to the size of a city, then the size of a pinhead. The outer layers of the star rush in to fill the gap, moving at a quarter of the speed of light. They crash against the core with unimaginable force. The impact creates a shockwave that rips the star apart. A supernova. It is a firework display on a galactic scale. For a few weeks, this single dying star outshines the entire galaxy of billions of stars. It scatters its gold and silver into the dark, planting seeds for future worlds. But we are interested in what gets left behind. As the bright clouds of the explosion drift away, the smoke clears. We look at the center. The star is gone. But something is there. If the star was large, a neutron star remains, a dense ball of matter. But if the star was truly a giant, gravity refuses to stop. It keeps crushing. It keeps squeezing. The core shrinks smaller and smaller. It becomes so heavy and so dense that it punches a hole in the fabric of the universe. It disappears from our sight. The light flickers out. The matter vanishes into a single point. a black hole is born. It is not a monster, it is a ghost. A quiet, dark memory of where a star used to be. We drift towards this new object. It is invisible against the black background of space. We can only see it because it blocks the stars behind it. It looks like a perfect circle of nothingness. A drop of black ink in a glass of clear water. It is peaceful here. The violence of the explosion is over. Now, there is only gravity, absolute and eternal. Imagine a heavy bowling ball placed on a soft mattress. The mattress curves down around it. If you roll a marble nearby, it will curve towards the ball. This is what a black hole does to space itself. It creates a deep valley in the dark. Anything that wanders too close simply follows the curve, sliding gently down into the deep. We are safe, though. We are just observers, floating far above the danger. We can admire the geometry of it, the perfect sphere, the absolute darkness. It is the most orderly object in nature. Simple, clean, silent. There is a strange comfort in its permanence. We drift closer to the dark sphere. We are approaching the edge, is less than Hasson. 2# is greater than scientists call this the event horizon. It sounds like a physical barrier, like a wall of stone. But in reality, there is nothing to touch. It is simply a shadow line in space. Imagine you are in a small boat, floating down a wide, lazy river. The water is calm, the sun is warm. Ahead of you, there is a waterfall. The event horizon is the edge of that waterfall. Above the edge, you can still swim back upstream. You can still return home. But once you cross that invisible line, the current becomes too strong. The water pulls faster than you can swim. In space, the river is made of gravity, and the swimmer is light itself. Light is the fastest thing in the universe. It travels at incredible speeds. But inside this boundary, even light is not fast enough to escape. Gravity pulls it back down, like a hand catching a ball. Because light cannot get out, we cannot see what happens inside. It is a private place, a secret kept by the universe, locked away from our eyes forever. As we linger near this silent boundary, something strange begins to happen. We are entering the realm of Einstein. He taught us that time is not rigid. Time is flexible, like a rubber band. Massive objects, like this black hole, stretch time out. They slow it down. Imagine we send a small probe, a robotic explorer, towards the horizon. We stay here, watching safely from a distance. As the probe gets closer to the darkness, we expect to see it vanish quickly. But that is not what we see. To our eyes, the probe begins to slow down. Its movements become sluggish, like a film running in slow motion. A second on the probe's clock takes a minute on ours. Then an hour, then a year. It is drifting through thick honey. The closer it gets to the edge, the slower it moves. Until finally, it seems to freeze. It never disappears. It just hangs there. A frozen image on the edge of forever. A photograph pinned against the dark. From the probe's perspective, it has already fallen in. It has crossed over. But for us, the outside observers, it remains caught in the past. A memory that refuses to fade. This slowing of time is one of the most soothing concepts in physics. It tells us that urgency is an illusion. We are so used to rushing, to deadlines, to the ticking clock. But here, in the presence of the giants, the clock stops ticking. The now stretches out into eternity. There is no late, there is no early. There is only being. The light from our frozen probe begins to change too. As the light struggles to climb out of the gravity well, it gets tired. It loses energy. The white light shifts to a soft yellow. Then to a warm, deep orange, like the embers of a dying fire. Finally, it fades into a deep, dull red. Astronomers call this redshift. It is the universe dimming the lights for us, is less than Hasson. 4# is greater than turning down the brightness, preparing for sleep. The object fades slowly from our sight, slipping into the infrared. It becomes invisible, not because it is gone, but because it is too quiet for our eyes to hear. We are floating in a place where time stands still. The worries of tomorrow are far away, moving at a speed that cannot touch you here. You are in the slow lane of the cosmos. You have permission to pause. To let the world spin on without you for a while. Just drifting, just watching. But the darkness is not empty. As our eyes adjust to this deep red silence, we notice a glow. The black hole is wearing a crown. A ring of light is circling the shadow. Let us turn our attention to the gold that surrounds the dark. We turn our eyes away from the center, away from the silence, and we look at the light that surrounds it. It is a beautiful paradox. The darkest object in the universe is often wrapped in the brightest blanket. Astronomers call this the accretion disk. But to us, it looks like a river of light. A cosmic carousel spinning slowly and gracefully around the dark hub. Imagine a ring of gold and amber, glowing softly against the black velvet of space. This ring is made of dust and gas, material that has wandered close to the giant. Gravity has caught it. But it does not fall in straight away. Instead, it circles. It flows like water circling a drain, but much slower, much smoother. It is a dance that has been going on for millions of years. As the gas spins, the particles rub against each other. Just like you might rub your hands together to create warmth on a cold night. This friction creates heat, and the heat creates light. The disk glows. On the outer edges, where the river moves slow, it is a deep, dull red. As we look closer to the center, the color shifts. It turns to a bright, warm yellow, then to a brilliant white. It is a visual masterpiece. A dark pupil surrounded by an iris of fire. Watching it spin is hypnotic. Round and round, steady and sure. There is no chaos here from our distance. Only a perfect, rhythmic motion. Like a wheel turning in the night. Sometimes, the black hole acts like a lighthouse. Not all the material falls in. Some of it is redirected. Powerful beams of energy shoot out from the top and bottom of the disk. They travel in straight lines for thousands of light years, drawing a path through the galaxy. They are the searchlights of the cosmos, sweeping silently through the dark. These beams help to create new stars far away. They push gas clouds together. Even in its hunger, the giant is a creator. It is planting seeds in the garden of space. It is part of the great cycle. Nothing is wasted. Nothing is lost. It is just recycled into light. We watch the golden disk spin for a while. The movement is soothing to the eyes. It reminds us of a potter's wheel or a vinyl record turning on a player. It hums with a low, steady vibration. The sound of the universe working exactly as it should. You are safe here. The gravity holds the disk in place. It holds the planets in their orbits. And it holds you in your bed. It is the same force. A heavy, comforting blanket that keeps everything grounded. As we pull back further, the golden ring becomes smaller. It becomes a bright star in the distance. We realize now that this is not a lonely object. It is part of a family. It lives in the heart of a galaxy. Let us widen our view. Let us see the home where this giant lives. We pull back now. We float backwards, away from the heat and the light. The golden ring becomes smaller. It shrinks until it is just a bright star among millions of others. We are looking at the bigger picture. We see our own home, the Milky Way. It stretches across the dark like a spilled glass of milk. A great spiral city of stars. It is vast, it is beautiful. And like every great city, it has a downtown. Deep in the center of the spiral, hidden behind thick curtains of dust, lives our own giant. Astronomers call it Sagittarius A*. It is a supermassive black hole, 4 million times heavier than our Sunday. It is the king of our galaxy, sitting quietly on its throne in the dark. For a long time, we did not know it was there. It is very quiet. It is not eating much right now. It is practically asleep. Only occasionally does it wake up to swallow a gas cloud, letting out a small flare of energy. Mostly, it just waits. While black holes represent gravity at its most terrifying and extreme, crushing massive stars into points of unimaginable, inescapable weight, this same universal force also has a much gentler, familiar side. We don't have to stay in those dark, destructive depths of the distant cosmos to see it at work. If we travel all the way back to the safety of our own night sky, we find a beautiful example of gravity in perfect, harmonious balance. It is a force that doesn't devour light or crush matter, but instead gracefully pulls at our earthly oceans, guiding the tides and softly illuminating our darkness. Locked in a delicate, eternal dance with our home planet, it is our closest celestial companion, the Moon. We are standing on the surface of the Moon. Our feet are planted on another world. The silence here is absolute. It is not the quiet of a library or a forest. It is a vacuum silence. Sound requires air to travel, and here there is no air. If a giant meteor were to crash into a mountain a mile away, we would feel the vibration in our boots. But we would hear nothing. It is a peaceful, heavy silence that presses against the ears. A silence that has reigned here for billions of years. We look up at the sky. Even though the sun is shining on the landscape around us, the sky is pitch black. Without an atmosphere to scatter the light, the stars are visible even during the day. They do not twinkle. They are steady, piercing points of diamond light. And there, hanging high above the horizon, is Earth. It looks 4 times larger than the Moon does from home. A brilliant marble of blue and white swirling in the dark. It is the only thing in the sky that changes. Everything else is fixed and eternal. We take our first step. We feel lighter instantly. Gravity here is only 1/6 of what we are used to. The heavy chains of Earth's pull have been loosened. We do not walk so much as we bounce. A slow motion glide with every stride. It feels dreamlike, effortless, like being underwater, but without the resistance of the water. Your body feels unburdened. We look around at the horizon. It feels closer than it does on Earth. Because the Moon is smaller, the ground curves away more sharply. The horizon is only a mile or 2 away. It creates a sense of intimacy. You are in a small, private bubble of visibility. Everything beyond that curve is hidden, waiting to be discovered. The line between the grey ground and the black sky is razor sharp. There is no haze to soften it. The light here is different too. On Earth, shadows are soft because the air scatters sunlight into them. Here, the shadows are absolute black. If you step behind a rock, you disappear into the void. The landscape is a mosaic of brilliant white highlights and ink-black darkness. It is stark and beautiful, like a black and white photograph brought to life. Nothing moves. There are no clouds drifting by, no grass waving, just the stillness of the stone. We are visitors in a museum of the ancient solar system. Nothing has eroded here. The rocks we see have sat in exactly the same position for aeons. On Earth, wind and rain wash history away. Here, history is preserved forever. A footprint left in the dust today will still be there in 10 million years. Perfectly crisp, unchanged by the passage of time. We are standing in eternity. We lower our gaze from the horizon to the ground beneath our boots. At first glance, it looks like simple, dry cement powder or grey sand. But this is not sand, and it is not soil in the way we know it. It is called regolith, a blanket of loose dust and broken rock that covers the entire moon. On Earth, sand is created by the ocean and the wind, which tumble rocks against each other for millions of years until they are round and smooth. But here, there is no wind and there is no water. Nothing has ever been smoothed down. Every single grain of dust here is jagged, sharp, and hooked like a tiny piece of broken glass. We kneel down slowly in the low gravity to look closer at this alien carpet. The layer of dust is deep, ranging from 10 to 50 feet thick in some places. It is the wreckage of billions of years of cosmic bombardment. Large meteors broke the bedrock into boulders, and smaller meteors smashed the boulders into stones. Then, for eons, tiny micrometeoroids no bigger than grains of sand have hammered the surface like rain. They strike the ground at incredibly high speeds, melting the rock instantly upon impact. This constant gardening turns the stone into a fine, charcoal grey powder mixed with tiny beads of glass. We reach out a gloved hand to touch the surface. The dust is incredibly cohesive. It wants to stick together. Because there is no atmosphere to protect it, the dust is constantly bombarded by solar radiation. This charges the particles with static electricity. The dust clings to everything it touches. It coats our boots in a layer of grey. It climbs up the legs of our spacesuits. It is a clingy, abrasive powder that finds its way into every crease and mechanical joint. The astronauts who walked here found that they could not brush it off. It was too stubborn. There is a strange smell associated with this dust, though we cannot smell it through our helmets right now. When the Apollo astronauts returned to their landing craft and took off their helmets, the cabin was filled with a distinct scent. They described it as smelling like spent gunpowder or wet ashes from a fireplace. It is the smell of activated minerals reacting with oxygen for the first time in history. It is the scent of a dead world briefly coming to life. We stand up and look at the colors of the plain. From Earth, the moon looks purely black and white, but standing here, we can see subtle variations. The ground is not a uniform gray. It shifts in tone depending on the minerals under our feet. Some areas have a slight brownish, earthy tint, hinting at iron in the soil. Other areas, particularly the dark seas or maria, have a very faint bluish hue. This blue comes from titanium trapped in the ancient basaltic lava flows. It is a monochrome world, but it has its own subtle and quiet palette. Scattered across the regolith are rocks of every shape and size. They do not line piles or riverbeds, they sit alone, dropped randomly by distant impacts. Some are small pebbles, while others are house-sized boulders. We approach a medium-sized rock to examine it. It is not weathered or rounded. It is covered in tiny pits, little dots where microscopic particles have struck it over the millennia. These represent zap pits, tiny craters on the rock itself. The rock sits in a small depression of dust, undisturbed for perhaps 1 million years. It is a sculpture of patience. The ground beneath us is also a landscape of craters. They are fractal in nature. The pattern repeats endlessly at every scale. We see large craters miles wide in the distance. But right at our feet, there are craters the size of a dinner plate. And inside those, craters the size of a coin. Every inch of this surface has been touched and retouched by the universe. The craters are shaped like perfect bowls. Because there is no atmosphere to slow objects down, they hit with maximum energy, exploding outward in a perfect circle. The edges are soft and rolled, smoothed over by the slow rain of dust. We walk carefully around the rim of a small crater. The inside is in shadow. The temperature difference here is extreme and hard to comprehend. The ground in the direct sunlight is baking hot, boiling at over 200 degrees Fahrenheit. But just inches away, in the shadow of the rock, the temperature plunges to hundreds of degrees below zero. There is no air to mix the warmth. You can have 1 foot in the fire and 1 foot in the ice. It is a world of thermal violence wrapped in visual silence. As we walk, we leave a trail behind us. The famous boot prints. The regolith compresses perfectly under our weight. It stamps the shape of the sole into the ground with absolute precision, like a mold. The ridges of the boot are sharp and clear. Because there is no wind to blow the dust away and no rain to wash it smooth, these prints are permanent. They are monuments to our presence. Unless a meteor strikes this exact spot, these footprints will outlast the pyramids of Egypt. They will likely outlast the human species itself. We pause to look at the sparkle on the ground. When the sun hits the regolith at the right angle, the ground seems to glitter. This is the Heiligenschein effect, or the holy glow. It is caused by those billions of tiny glass beads reflecting the sunlight back at us. It makes the dusty, dead ground look like it is covered in morning dew or frost. But it is a dry shimmer, is less than Hasson. 3 is greater than a trick of the light and the glass. It reminds us that even this grey garden has its own kind of magic. We stand still in the middle of this vast grey plain. The feeling of isolation is profound, but it is not scary. It is a clean, uncluttered feeling. The visual noise of earth, the trees, the cars, the buildings is all gone. There is only the rock, the dust, and the black sky. It quiets the mind because there is nothing here to process. Just simple, geometric shapes and the slow drift of our own breathing. We are alone with the stone. We leave the rugged, cratered highlands behind us and walk down a gentle slope. Ahead of us lies a change in the landscape so vast that it is hard to comprehend. We are stepping onto one of the great dark patches of the moon. The early astronomers looked up at these smooth, dark shapes and thought they were filled with water. They gave them romantic names that sounded like dreams. The Sea of Tranquility, the Sea of Serenity, the Sea of Rains. But as we walk out onto this plain, we realize there is no water here. There is not a single drop of moisture in this Sea of Rains. Instead, we are standing on a monumental ocean of solid rock. This is a world of basalt. Billions of years ago, the moon was young and its heart was hot and molten. When massive asteroids struck the surface, they cracked the crust open. Deep from the interior, great floods of liquid lava rose up to fill the wounds. It was a firestorm that covered millions of square miles. But over time, the fire cooled. The liquid rock settled, smoothed out, and froze into place. Today, we are walking on the surface of that frozen lake. It is a perfect record of a calm moment that happened 3 billion years ago. The ground here feels different beneath our feet. The dust is darker, richer, and heavier. It contains more iron and magnesium than the grey highlands we came from. This darker color absorbs more sunlight, making the ground look like a deep charcoal velvet stretching to the horizon. Because it is so flat, walking here is easier. It feels like walking on a paved highway that has been dusted with powder. We can glide forward with long, loping strides, covering great distances without effort. There are fewer obstacles here, fewer boulders to navigate. Just an endless open expanse of dark calm. The flatness of the Maria creates a strange visual trick. On Earth, our eyes use trees, buildings, or mountains to judge distance. Here, on this featureless plain, there is no sense of scale. A boulder in the distance might be the size of a car, or it might be the size of a house. Without walking up to it, we simply cannot tell. The horizon looks deceptively close, yet we can walk for hours and it never seems to change. It creates a feeling of being suspended in a void. a peaceful disorientation where the only direction that matters is forward. We are small dots moving across a giant canvas of stone. As we move deeper into the sea of tranquility, we notice winding channels carved into the flat surface. These are the sinuous rills. They look like riverbeds that have dried up in the sun. They wind and snake across the landscape with beautiful organic curves. But water never flowed here. These were once immense tubes of flowing lava, underground tunnels of fire. When the lava drained away, the roof of the tunnel collapsed, leaving this long, winding canyon behind. We stand at the edge of one and look down. It is a shadow valley, a scar that tells the story of the moon's active past. Now, it is just another quiet place for the shadows to rest. We stop to look back at the Earth hanging in the sky. From this dark plane, the Earth looks even brighter. It is the Earthlight that illuminates our path. Even when the sun goes down on the moon, it never gets truly pitch black if the Earth is full. The light reflecting off our home planet is strong enough to cast shadows here. It bathes the dark basalt in a soft, ghostly blue glow. It is a comforting nightlight in this vast, empty room. We can see the clouds swirling over the Pacific Ocean. We can see the brown of the continents. It looks so alive compared to the stillness around us. These dark seas are what make the man in the moon. When we look up from Earth, our brains try to find patterns in the light and dark patches. We see a face, or a rabbit, or a dragon. But standing here, the pattern dissolves. There is no face. There is only geology. There are only vast plains of cooled lava that have sat undisturbed for eons. The eyes of the man in the moon are just giant basins filled with rock. The mouth is just a shadow. But losing the myth does not make it less beautiful. The reality of this silent world is far more majestic than any story we invented. The silence here feels deeper than in the highlands. Perhaps it is the color of the ground, or the lack of craters to break up the view. It feels like a place of deep meditation. The moon is tidally locked to the Earth, which means it rotates at exactly the same speed that it orbits. It keeps the same face pointed at us forever. These seas are always watching Earth. They are the loyal guardians that never turn away. There is a sense of eternal patience in that gaze, holding its position, holding the connection between the two worlds. We sit down on a flat slab of basalt. The rock is cold and hard, but stable. We let our eyes drift over the flat horizon. There is nothing to count here. No trees to number, no waves to time. Just a single, unified expanse of existence. It invites the mind to stop thinking. It invites the thoughts to settle down, just like the lava settled down billions of years ago. To become smooth. To become solid. To become still. We lift off gently from the smooth basalt plains of the dark seas. We glide low over the surface, heading towards the eastern edge of the moon. As we cross the terminator line, the boundary between day and night, we enter a realm that no human eye saw until the space age. We are approaching the far side. Often called the dark side, this is a misleading name, for it receives just as much sunlight as the front. It is only dark to us because we never see it. The moon is locked in a gravitational dance that keeps one face turned away from Earth forever, hiding its back like a shy dancer. As we round the curve, the Earth sinks lower and lower behind us. Finally, it slips below the horizon and disappears completely. For the first time in our journey, we are truly alone. The bright blue marble that has watched over us is gone, blocked by thousands of miles of rock. This creates a unique kind of solitude. Here, you are cut off from every voice, every signal, and every picture from home. It is the only place in the solar system where the Earth is totally invisible. The landscape below us changes dramatically. The smooth, dark lakes we walked on earlier are almost entirely missing here. Instead, the ground is a chaotic, rugged wilderness of white highlands. It looks beaten and bruised, covered in so many craters that they overlap each other like footprints in a crowded room. There is no flat place to rest the eye. It is a jagged ocean of peaks and valleys, stretching endlessly in every direction. Scientists believe the crust is thicker on this side, which prevented the lava from bubbling up to form the smooth seas we know so well. We land in the center of a massive ancient basin. The silence here has a different quality. It is a radio-quiet silence. On the near side, the moon is bombarded by the constant radio chatter of Earth, our TV broadcasts, our radar, our communications. But here, the mass of the moon acts as a giant shield. It blocks all the electronic noise of humanity. This is the quietest place in the neighborhood of the sun. If you had a radio receiver here, it would pick up nothing but the gentle hiss of the universe itself. The static of the Big Bang whispering from the beginning of time. We walk towards the rim of a crater named Daedalus. The walls rise up steep and sharp against the stars. Because there is no weather to wear them down, the mountains of the moon look different from mountains on Earth. They do not have majestic snow-capped peaks or rolling green foothills. They are piles of rubble, massive mounds of grey debris pushed up by explosions. They look raw and industrial, like the spoiled tips of a giant mine. Yet in their stillness, they have a solemn dignity. The shadows here seem longer and deeper. Without the earthlight to soften them, the night on the far side is absolute. When the sun goes down here, you are plunged into a darkness so thick it feels physical. You are standing on the deck of a spaceship looking out into the void with no anchor to hold you to the known world. It is a frightening thought, but also a liberating one. To be so completely hidden is a rare form of privacy. A secret kept by the cosmos. We look down at the ground again. Even here, on the hidden side, the dust is churned and patterned. We see bright rays of white material stretching out from fresh craters. These ejecta rays look like splashes of white paint thrown across a grey canvas. They tell us that even though this side sleeps, it is not dead. It is still collecting history. Every scar is a memory of an event that happened millions of years ago, preserved in perfect clarity. We find a flat rock and sit, facing away from where Earth would be. We look out into the deep field of stars. Without the glare of our home planet, the Milky Way is brighter here than anywhere else. It looks like a storm cloud made of light. You can see the colors of the stars, orange, blue, and gold, burning steadily in the vacuum. It reminds us that the moon is just a stepping stone. A small island off the coast of a much larger continent. Sitting here, in the shadow of the moon, we feel the true scale of the galaxy wrapping around us. We leave the rugged wilderness of the far side and turn our attention to the bottom of the world. We are approaching the lunar South Pole, a region that is dramatically different from the equator. Here, the sun does not rise high in the sky and then set. Because the moon stands almost perfectly upright with very little tilt, the sun simply skims along the horizon. It circles around us, casting shadows that are 50 miles long. This low angle of light creates a landscape of extreme contrast, where the difference between light and dark is absolute. It is a place of eternal twilight, caught forever in the golden hour of dawn. We stand on the rim of a massive crater named Shackleton. The rim towers above us, bathed in constant, brilliant sunlight. These high points are called the peaks of eternal light. Because of their height and location, the sun never sets on them. They have been warm and illuminated for billions of years, acting as beacons in the grey landscape. Standing here, you would never see nightfall. You would simply watch the stars rotate overhead while the ground remains washed in gold. But we look down, over the edge of the cliff, into the bottom of the crater. Down there, the floor is plunged into permanent shadow. The sun is too low to ever peek over the rim. This means the bottom of this crater hasn't seen a single photon of sunlight in 2 billion years. It is one of the darkest places in the universe. It is a cold trap, a natural refrigerator that preserves everything that falls into it. The darkness is so complete that looking into it feels like looking into a deep, velvet well. We descend slowly into the shadow. As soon as we cross the line from light to dark, the temperature plummets. We are entering a realm deeper than freezing. It is nearly 400 degrees below 0 Fahrenheit. This is colder than the surface of Pluto. It is colder than the empty space between the stars. In this extreme cold, the atoms themselves seem to slow down and almost stop vibrating. It is a stillness that goes down to the molecular level. We turn on our lights to see what is hiding in the dark. The ground sparkles, but not with rock. We are looking at water ice. This is not a smooth skating rink like a frozen lake on Earth. It is dirty ice, billions of tiny crystals mixed in with the grey regolith. It looks like soil that has been frosted over by a hard winter. This water was delivered by comets that crashed into the moon eons ago. On the rest of the moon, the water evaporated instantly into space. But here, in the cold trap, it was captured and frozen instantly. It has remained here, unchanged and untouched, since the time dinosaurs walked the Earth. This ice is hard as granite. At these temperatures, water ceases to act like a liquid and acts like a mineral. If you tried to chip it with a pickaxe, the metal would likely ring or shatter. It is a fossil of the early solar system. Trapped in the dark, safe from the sun, safe from the vacuum. It is a sleeping resource, waiting patiently in the dark. We realize that the driest desert we saw earlier actually hides an ocean in its shadows. The silence in the crater is heavy. Because there is no thermal expansion or contraction here, the rocks do not crack or shift. The moonquakes that happen elsewhere are dampened here by the deep freeze. It is a place of absolute stability. Nothing moves. Nothing changes. Nothing degrades. If you dropped a feather here, it would lie exactly where it fell for eternity. It is the ultimate archive of history. We look back up towards the rim of the crater. We can see the sliver of the sunlit peaks glowing high above us like a halo. The contrast is breathtaking. Above, infinite light and warmth. Below, infinite darkness and cold. Two worlds existing side by side, separated by just a few miles of rock. It reminds us of the balance of the cosmos. Energy and entropy. Motion and rest. Dancing together in silence. We stand in the cold for a moment longer, respecting the stillness. The cold feels protective here, like a vault. It keeps secrets safe. It stops the clock. In a universe that is always rushing forward, this crater is a pause button. A place where time waits for us. We feel our own internal clock slowing down to match it. The beat of our heart seems to echo the slow, frozen rhythm of the ice. We leave the freezing shadows of the poles and drift back towards the equator, towards the sunlit plains of the near side. Scattered across this vast grey landscape are tiny islands of metal and gold. These are the resting places of the machines that came from Earth. We approach one of these sites slowly, drifting like a ghost over the regolith. It sits in the middle of a flat, basaltic plain, undisturbed for over half a century. It is the descent stage of a lunar module. It looks like a strange, geometric insect made of foil and aluminum. Its forelegs are planted firmly in the dust, wrapped in gold insulation that still gleams brightly in the sun. There is no rust here. There is no wind to tear the foil, and no rain to corrode the metal. It looks exactly as it did the moment the astronauts climbed the ladder and blasted off. leaving it behind as a monument to their departure. Around the base of the machine, the ground is a chaotic map of footprints. We can see the tracks where they walked to set up the flag. We can see the path where they dragged their tools. The boot prints are sharp and deep, the tread patterns perfectly preserved. They look fresh, as if they were made just 5 minutes ago. But looking closely, we see that the flag they planted has changed. The nylon fabric has been bleached completely white by decades of harsh ultraviolet light. It is no longer a flag of a nation, it has become a flag of surrender to the sun. A white square standing stiffly on its wire frame, saluting the silence. A little further away, we find a lunar rover. It is parked casually, as if the driver just stepped out for a break. Its wheels are made of wire mesh, designed to grip the soft dust without sinking. The fenders are dusty, coated in the same grey powder that covers the hills. The high-gain antenna points back towards Earth, forever waiting for a signal that will never come. The seats look like lawn chairs, simple and functional, sitting empty in the vacuum. There is something incredibly peaceful about this abandoned car. It is not a wreck, it is a display piece in the quietest gallery in the universe, waiting for visitors who may not come for another 1,000 years. We move to another site, miles away, where a different kind of visitor sits. This one has no seats and no windows. It is a robotic surveyor, a Soviet lunacod. It looks like a bathtub on 8 wheels, with a round lid open to the sky. It has been sleeping here since the 1970s. Its solar panels are covered in a fine layer of dust, but underneath, the machinery is intact. It drove for miles across the Mare Imbrium, controlled by men sitting in a room in Russia. Now, it is just another rock among the rocks. A metal tortoise that has gone into eternal hibernation. Among these large machines, there are smaller, simpler objects. We find a panel of mirrors sitting on the ground. This is a laser-ranging retroreflector. It is about the size of a suitcase, filled with corner cube prisms. It is the only experiment from the Apollo era that is still working today. Every night, scientists on Earth shoot a laser beam at this exact spot. The mirrors catch the light and bounce it straight back to the observatory. By timing how long the journey takes, they can measure the distance to the moon down to the millimeter. It is a heartbeat of light, connecting the two worlds. Pulse, return, pulse, return. A silent conversation that continues while the world sleeps. We realize that these sites are time capsules. On Earth, our history is buried by new cities, or washed away by floods, or overgrown by forests. Nature reclaims everything. But here, there is no nature to take it back. The moon is a faithful keeper of memories. The hammer that was dropped, the golf ball that was hit, the family photo that was left on the regolith. They are all safe here. They are held in a state of suspended animation. The moon protects them with its stillness. It treats a discarded camera lens with the same respect it treats a billion-year-old crater. We float above the landing site, looking down at the pattern of activity frozen in the dust. It feels less like an abandonment and more like a pause. As if the scene has been paused on a video player. The stillness is heavy and profound. It invites us to pause too, to stop our own internal motion, to become as still as the gold foil on the lander, to let the dust settle in our own minds, standing watch over the silent history of the moon. We lift off from the dusty surface one last time, drifting upwards into the silence of space. We float in the void between the two worlds, looking at the invisible connection that binds them together. The moon is not just a rock floating aimlessly in the dark, it is held on a tight leash by the Earth. But the moon pulls back with a gravity of its own, an invisible hand reaching out across 250,000 miles. It is a heavy, silent embrace that has lasted for 4.5 billion years. They are dancing partners, spinning around a common center, locked in a rhythm that neither can break. We look down at the blue oceans of Earth. From this distance, we can see the effect of the moon's touch. As the moon orbits, it drags the water of the oceans with it, creating a bulge that travels across the planet. This is the tide. It is the breathing of the world. Inhale, and the tide comes in, filling the bays and lifting the ships. Exhale, and the tide goes out, revealing the sand and the secrets of the shore. It is a slow, deep respiration that happens twice a day, every day, without fail. It is a clock made of water, ticking slowly in time with the orbit. This movement of water is powerful, but it is also gentle. It creates friction against the ocean floor, a massive global resistance. This friction is actually acting as a brake on the Earth's rotation. Very slowly, the moon is forcing the Earth to slow down. Billions of years ago, a day on Earth was only 6 hours long. Everything was spinning frantically fast, is less than Hasson. 5 is greater than, but the moon has calmed us down. It has stretched our day into 24 hours. It is still doing it now, lengthening the day by a tiny fraction of a second every century. The moon is a gift of time, giving us longer nights to rest. While the Earth slows down, the moon is slowly drifting away. It is stealing energy from the Earth's spin to push itself into a wider orbit. Every year, the moon moves about 1.5 inches further away from us. It is a retreat so slow that it is invisible to the human eye, yet it is measurable and real. It is a long, slow goodbye that will take billions of years to complete. But for now, it is still close enough to light our way. It hangs in the sky like a lantern, watching over the sleeping planet with a steady gaze. This gravitational bond creates a sense of stability. Without the moon, the Earth would wobble chaotically on its axis. The climate would swing wildly from hot to cold, and the seasons would be unpredictable. The moon acts as a stabilizer, a heavy anchor that keeps the Earth tilted at the perfect angle. It creates the rhythm of spring, summer, autumn, and winter. It is the reason we have a predictable pattern of life. It is the silent guardian of our seasons, holding the world steady so that life can flourish. We feel this pull in our own bodies. We are made mostly of water, just like the oceans. While the tidal force on a human is tiny, we are still part of this great cosmic system. We live in the rhythm of the orbit. The word month comes from the word moon. Our calendars, our festivals, and our nights are defined by the waxing and waning of this silver sphere. It is woven into the fabric of our time. When we look up at it, we are looking at the metronome of our history. The light from the moon is soft and reflected. It is sunlight that has been filtered, bounced off the grey dust, and sent back to us. It is cooler than sunlight. It does not demand action. It invites reflection. Under the moonlight, the world loses its sharp edges and its bright colors. Everything becomes silver and shadow. It is a light made for sleeping. A light that tells the brain it is time to wind down and let go of the day. We float further back until the moon and the earth are both in view. Two spheres floating in the endless velvet dark. They look peaceful together, connected by invisible threads of gravity and time. The tension between them is perfectly balanced. Not too close, not too far. Just a gentle, eternal swinging motion, rocking the cradle of the night. The journey across the grey world is finished. We have walked the dusty plains, stood in the frozen shadows, and watched the earth hang in the ink-black sky. Now, the visual details begin to fade away. The sharp edges of the craters soften into a blur. The contrast between the bright white highlands and the dark seas melts into a single soothing shade of silver. The moon is no longer a place of geology and science. It is returning to what it has always been for us. A quiet, glowing presence in the night. A nightlight that never burns out. We feel the gravity of the earth pulling us gently back home. Not with speed, but with a slow, comfortable drift. We leave the vacuum silence behind and return to the soft atmosphere of sleep. The heavy stillness of the lunar rock settles into your own bones. You feel solid. You feel grounded. Just as the moon is anchored in its orbit, you are anchored in your bed, held safely in place by the weight of the blankets. The light of the moon is a cool light. It does not ask you to wake up. It does not ask you to work or to think. It only asks you to rest. It washes over the world, turning the busy colors of the day into a peaceful monochrome. Under this light, the mind can finally stop spinning. The thoughts that have orbited your head all day begin to slow down. As we bathe in the gentle, silvery glow of moonlight, it is easy to forget that this silent companion is locked in an eternal, frozen embrace with Earth. Over billions of years, the relentless pull of gravity has slowed its rotation until it simply stopped spinning from our perspective, showing us the exact same face night after night. But as we leave this quiet, tidally locked satellite behind and look further out into the deep, dark ocean of the cosmos, we find a world that refuses to stand still. Out there, shining like a lone, rust-colored ruby in the endless void, is a dynamic planet with its own restless dust storms, ancient riverbeds, and a day that lasts almost exactly as long as our own. We are setting our sights on the red planet. We are heading to Mars. This is the fourth world from our Sun, orbiting at a vast distance that places it on the very edge of the inner solar system. It moves in a slow, wide circle, taking a great stretch of time to complete a single journey around its star. Think of it as a world that moves with a different pulse, where the seasons linger nearly twice as long as the years we have always known. Now imagine reaching the very edge of the atmosphere, which feels much thinner and more delicate than the heavy air we left behind. This layer is primarily made of carbon dioxide, creating a dry and quiet environment that wraps around the entire globe like a thin veil. The atmospheric pressure here is incredibly low, representing only a tiny fraction of what we feel at sea level on our home world. It is a vast, silent desert of air, waiting for us to settle into its rhythm while the day slowly fades away. Our descent is slow and steady, moving through hazy layers that hold a fine, microscopic dust suspended in the air. This dust is lifted by gentle winds and carried across the massive plains and deep, ancient craters that mark the surface. It is rich in iron oxide, the very same material that causes metal to rust, giving the entire landscape its legendary and signature color. In a sense, the whole world is gently aging in the cold, its surface turning to powder under the steady gaze of a distant sun. Take a slow breath and let your jaw unclench as we touch down on the solid, unmoving ground. The surface of this world is ancient and undisturbed, covered in rocks and pebbles that have sat in the same place for countless ages. The temperature here is much lower than anything we are used to, often dropping to an intense, biting cold during the long nights. We have arrived in a landscape of profound quiet, where the only sound is the occasional drift of the thin wind over the stones. The horizon on this world feels surprisingly close, curving away more quickly than the horizon we see when we stand on our own ground. Because this planet is significantly smaller than Earth, its physical scale creates a sense of intimacy and closeness with the land. The gravity is much lighter here, providing a gentle pull that makes every movement feel a bit more effortless. This lighter touch helps the weight of the day feel as though it has been lifted away from your shoulders, leaving you light and at peace. We look out over a vast plain that stretches toward the distance, showing us a world of simple shapes and soft, muted colors. Large rocks sit scattered like silent monuments, worn down by the immense passage of time and the slow, steady movement of the air. There are no forests to rustle in the breeze and no oceans to ripple under the light, leaving only the open, reaching desert. It is a place of absolute stillness, perfect for a mind that is ready to find its own rest in the deep, quiet cold. We look down at the ground beneath our feet, seeing a layer of loose rock and dust called regolith that covers the entire surface like a thick, dry blanket. This material is a mixture of crushed volcanic rock and fine minerals that have been ground down over unimaginable stretches of history. It protects the ancient bedrock hidden below, keeping the secrets of the planet's formation safe from the cold, reaching vacuum of space. The texture is fine and powdery, sticking to the surfaces of every stone we pass as we move slowly across the silent plain. The reddish color that defines this world is actually a very thin layer of iron oxide, much like the soft rust we find on old metal objects. In many places, this colorful coating is only a few millimeters thick, yet it is enough to paint the entire globe in shades of orange and deep red. Beneath this dusty layer, the rocks are often dark and gray, revealing the volcanic origins of the crust that sit beneath the dust. We can see the contrast where the wind has swept the ground clean, showing the darker path of the planet's true face. Scanning the horizon, we see the jagged rims of ancient impact craters that break the flat surface of the vast open plains. Unlike our home world, where rain and wind eventually wash away these marks, the craters here remain almost perfectly preserved for eons. They vary in size from small, shallow pits to massive basins that stretch for hundreds of miles across the reaching landscape. These scars tell the story of a time when the solar system was a much more crowded and chaotic place than it is tonight. You can simply listen and let your mind rest as we explore these quiet, ancient features of the land. The air is so thin that sound travels differently here, muffled and soft in the incredible openness of the desert. We feel the deep stillness of the environment, a place where time seems to have slowed down to a gentle, patient crawl. There is no rush to move forward, as the landscape has waited for millions of years for this very moment of observation. In the low-lying areas of the craters, the wind has gathered the sand into beautiful rippled dunes that stretch across the floor. These dunes look like frozen waves on a dark, silent ocean, staying perfectly still for months or even years at a time. Every so often, a very gentle breeze might shift a few grains of sand, slowly and quietly reshaping the patterns in the dark soil. It is a slow and meditative process of change that happens in total isolation under the light of the pale sun. Scattered across the dusty ground are millions of tiny, round grey pebbles that look like small berries resting in the sand. These are actually concentrations of a mineral called hematite, formed in the presence of liquid a very long time ago. They sit nestled in the red dust, creating a subtle and beautiful texture on the surface of the vast, silent plains. We see how they catch the light, reminding us that this dry world once held very different and much wetter conditions. Occasionally, we might see a slender column of dust rising and spinning slowly across the flat, open land. These are dust devils, small whirlwinds powered by the warmth of the sun hitting the cold, dry ground. They dance across the landscape for a few minutes, lifting the red soil high into the air before vanishing back into the clear salmon sky. They leave behind winding traces on the ground, like the delicate and temporary handwriting of the wind itself. Looking up, we notice the sky is not the blue we know, but a pale salmon color during the middle of the day. This happens because the fine dust particles in the atmosphere scatter the light differently than the air on our home world. The sun looks like a small, bright coin in the distance, providing only a fraction of the warmth and light we are used to seeing. This soft, muted lighting gives the entire world a dreamlike quality that feels both distant and deeply peaceful. We pass by large rocks that have been sculpted into strange, smooth shapes by millions of years of wind erosion. Some of these stones have polished faces, while others are pitted with small holes created by ancient gas bubbles trapped in the lava. They stand like silent witnesses to the planet's long history, unchanging and resolute in the face of the eternal cold. We can see the layers in the rock, each one representing a different chapter of the world's long and quiet life. Let your shoulders drop and allow the day to fade out as we sit among these ancient, unmoving stones. There is a deep comfort in the permanence of this landscape, where everything stays exactly as it is for eons at a time. We are simply observers here, guests in a land that values silence and stillness above all else. As the light continues to soften, we prepare to look even closer at what lies beneath the dusty surface. The ground beneath our feet is mostly made of basalt, a dark volcanic rock that formed when lava cooled on the surface long ago. This rock is heavy and dense, making up the vast majority of the planet's thick, solid crust. In some areas, the basalt has cracked into geometric pillars, creating a landscape that looks like a carefully carved city of stone. It is a reminder of the powerful volcanic forces that once shaped the world we are walking upon in the dark. In the early morning hours, a thin layer of frost can sometimes be seen coating the tops of the flat, red rocks. This frost is not always made of water ice, but often consists of frozen carbon dioxide, which we know as dry ice. It glitters briefly in the pale, early light, before the rising sun turns it back into a thin, invisible gas. This fleeting moment of brightness is one of the few changes that happens on the surface during the course of a day. Moving across the terrain feels different here because the gravity doesn't pull on us quite as hard as we have always been used to. Every movement is lighter, and the silence of the desert seems to absorb every sound before it can travel very far. This physical lightness helps the mind feel a bit more free, as if the heavy thoughts of the day are being left behind in the red dust. We are traveling through a world of peace, where the only rhythm is the slow and steady turn of the planet. Now imagine sinking far beneath the dusty plains, moving away from the light and into the cool, silent layers of the planet's hidden interior. At the very center lies a dense core made primarily of iron and nickel, serving as a heavy and silent anchor that holds the entire world together from within the dark. This heart is an immense structure that provides the solid foundation for the landscape above, resting in a state of eternal and unchanging peace. Think of this core as a quiet engine that has mostly run out of its original heat after billions of years of existence. Long ago, this spinning center generated a powerful magnetic shield that protected the atmosphere from the harsh and constant solar wind. Today, that global shield is gone, leaving only invisible ghosts of magnetism trapped in the oldest rocks of the crust as a memory of what once was. Surrounding this metallic center is a vast mantle of heavy rock that stretches for thousands of miles in every direction. In the distant past, this layer was much more active, fueling the massive volcanoes that now sit perfectly silent and cold on the surface. Today, the mantle has cooled significantly, becoming a solid and stable floor that holds the remaining warmth of the planet's birth with incredible patience. Above the mantle sits the crust, a rigid and unmoving shell of stone that wraps the planet in a firm and steady embrace. This outer layer is much thicker than the crust of our own world, providing a deep and stable floor for the red deserts to rest upon. It is a single, continuous shell that has remained fixed for ages, allowing the land to support the weight of towering mountains without ever shifting or sliding. Because there are no moving tectonic plates here, the features of the surface are rooted deep into the planet's permanent structure. Without continents drifting and sliding, volcanic vents stayed in the same spot for millions of years, allowing them to grow to impossible sizes. This geological stability is what allowed the landscape to preserve its ancient face, turning the surface into a vast and silent museum of time. As we drift a little deeper into these quiet layers, let your shoulders drop and feel the weight of your own body resting securely. There is nothing you need to solve right now, and no place you need to be other than this moment of calm. Let the day fade a little more as we listen to the slow, heavy heartbeat of the planet beneath the dust. Although the planet is mostly quiet, it still experiences occasional movements known as marsquakes that ripple through the ancient stone. These are not caused by plates rubbing together, but by the cooling and shrinking of the planet's interior over the slow passage of time. They are subtle tremors, like a soft sigh from a sleeping giant, reminding us that even the most silent worlds are still alive in their own patient way. The overall density of this world suggests a core that is rich in lighter elements like sulfur, mixed into the iron in a unique celestial recipe. It is a world made of slightly different ingredients than our own, producing a landscape that values weight and stillness above all else. We feel the physical reality of this structure, a heavy ball of rock floating gracefully through the void while the stars watch from above. Faint warmth still flows very slowly from the dark interior toward the cold surface, though it is only a fraction of the energy found on more active worlds. This heat is the last remnant of the intense energy generated during the planet's violent formation, moving through the rock at a pace that is almost impossible to measure. We rest in the knowledge that even the coldest worlds have a lingering, hidden warmth deep inside their rocky hearts. Scientists study these internal layers by listening to how vibrations travel through the ground after a distant impact or a quiet quake. Each wave of energy acts like a soft light, revealing the different textures and densities of the core, the mantle, and the thick crust. This is how we map the invisible, using sound and vibration to see into the deep dark of a world we have never touched with our own hands. As the interior continues to cool, the planet very slowly contracts, causing the rigid crust to wrinkle and crack in certain places. These long, winding ridges are the physical signs of the world's slow and steady cooling process over the eons of its life. They are like the lines on an ancient, wise face, telling the story of billions of years of existence in the deep and silent cold. The silence of the interior is perhaps the most profound of all, a place where no wind ever blows and no sun ever reaches. It is a world of absolute darkness and steady pressure, where the heavy rocks have sat undisturbed since the very beginning of the solar system. We can imagine the stillness of these deep layers existing in a state of eternal and unchanging rest as we prepare to return to the dusty surface. While the hidden core remains heavy and silent, the surface of the planet has become a place where our own world and this distant neighbor finally meet. For thousands of years, we only knew this world as a bright red spark in the night sky, a wandering star that moved differently than all the others. We gave it names and told stories about its fiery color, never knowing that one day we would send our own mechanical eyes to walk upon its ancient dust. This connection has grown from distant curiosity into a quiet, physical presence that rests on the copper-colored plains. Our first clear views of this neighbor came through the glass lenses of early telescopes, revealing dark patches and white poles that changed with the seasons. We watched from an immense distance, imagining the vast deserts and the cold wind that might be blowing across the ancient craters. This long-distance fascination eventually turned into a bridge made of radio waves and metal, allowing us to touch the surface of a world we once only dreamed of. It is a slow and respectful introduction between two worlds that have shared the same solar system since the very beginning. The first robotic travelers we sent were small and brave, landing with parachutes and large bouncing airbags to cushion their arrival on the rocky terrain. They were the pioneers of our presence here, sending back the very first close-up images of a horizon that no human eye had ever seen. These early missions showed us a landscape that was even more beautiful and desolate than we had imagined in our stories. They paved the way for the more complex machines that now call this Red Desert their permanent home. Now imagine following the path of these mechanical explorers across the red dust while you let your mind rest. They move with incredible slowness, rolling over the sand on metal wheels that leave long, straight tracks across the ancient soil. There is nothing you need to solve right now, so just let your thoughts drift with the steady movement of the rovers as they travel. Each one is a masterpiece of balance, designed to survive in a place where no human could easily stand without help. These rovers are powered by the gentle light of the sun, or by tiny internal heaters that keep their delicate parts warm during the freezing nights. They work through the deep silence while the rest of the solar system sleeps, clicking their cameras and extending their robotic arms to touch the stones. Some of these visitors have worked for much longer than we ever expected, surviving great dust storms that covered the entire globe in a copper haze. They became legendary for their endurance, climbing steep hills and descending into deep craters to find clues of the past. When their batteries finally faded and their missions came to an end, they remained exactly where they stopped, becoming permanent monuments in the silent desert. They are now part of the landscape themselves, slowly being covered by the same fine red dust that they came here to study. There is a peacefulness in their rest, as they have become a permanent part of the history of this distant world. We look at them not as discarded machines, but as silent witnesses to our first steps into the great unknown. Newer and larger rovers have since joined them, equipped with sophisticated lasers and drills to look inside the rocks for the building blocks of life. They move with a quiet, electric hum, stopping frequently to examine a pebble or a patch of sand that catches their electronic eyes. These modern explorers are the artists of this world, sending back high-definition panoramas that allow us to feel as if we are standing right there with them. They reveal the texture of the mountains and the soft colors of the dunes with incredible clarity. We have even sent a small helicopter to fly through the thin, cold air, proving that we can reach above the dust and see the world from a new perspective. These flights are short and delicate, lifting just a few feet off the ground before settling back into the profound stillness of the plains. They represent the furthest reach of our ingenuity, a tiny hum of activity in a world that has known only the sound of the wind for eons. It is a quiet achievement that echoes across the vast and empty landscape, reminding us of our own ability to rise. Even though we are not there in person, our presence is woven into the names we have given to every hill, valley, and individual rock. We have mapped the terrain with the same care we use for our own home, turning a foreign landscape into a place that feels familiar and cherished. This naming is an act of friendship, a way of bringing this distant neighbor into our own human story of exploration. It allows us to feel a sense of belonging in a place that is an unimaginable distance away from our own bed tonight. As we look at the tracks in the dust, we realize that they will remain there for a very long time, protected by the lack of rain and the gentle nature of the air. They are a record of our visit, a quiet signature left on the face of the red planet that may last for thousands of years. We rest in the knowledge that while we are here, we are just the latest chapter in a story that began long before us. The footprints of our machines are the only marks on a world that values its ancient, undisturbed silence. Our relationship with this planet is also found in the music and stories we have created to honor its mysterious and beautiful presence in the sky. We have looked at the red dot in the night and seen it as a symbol of strength and of our own potential future among the stars. This cultural connection is just as strong as the physical one, weaving the planet into the very fabric of our history. It is a bond that grows stronger with every image sent back across the dark void, bringing the distant closer to our hearts. Settle in and let this stay calm, soft, and steady as we think about the dreams of one day seeing these vistas with our own human eyes. We imagine watching a blue sunset from the edge of a great, silent canyon, where the air is still and the distant stars are bright. Until then, we are content to travel through the data and the images, letting our imagination fill in the gaps of the quiet landscape. It is a journey of the mind, a peaceful exploration that brings the wonders of the cosmos into our own quiet rooms. We look toward the poles of this world, where the landscape shifts from red dust to a brilliant, shimmering white. These polar caps are massive reservoirs of frozen water and carbon dioxide, stretching across the northern and southern reaches of the globe. They are not just frozen shapes, but the planet's way of breathing, as a thick layer of dry ice forms and then vanishes with the steady passing of the seasons. This vast cycle of freezing and thawing moves immense amounts of gas between the ground and the thin air in a rhythm that has continued for millions of years. Beneath the dusty surface of the mid-latitudes, we find even more hidden layers of ice locked away in the soil. Massive glaciers, covered by a protective coating of rock and debris, sit silently in the shadows of mountains and inside deep, ancient craters. This underground ice has remained stable for ages, shielded from the sun's rays by the very earth that holds it. It is a hidden world of blue and white, buried just beneath the copper-colored ground we walk upon tonight. The air itself holds its own secrets, containing tiny amounts of gases that tell us about the planet's mysterious history. We detect traces of methane that appear and disappear in certain regions, hinting at activity deep underground that we cannot yet see. Scientists watch these invisible plumes with great interest, wondering if they come from the shifting of rocks or something more profound. It is a subtle puzzle, a small whisper of movement in a world that otherwise seems perfectly still. Let the day fade a little more, as there is nothing you need to solve right now in this moment of quiet. Take a slow breath and feel the weight of your body resting securely while we drift further into the mysteries of the cold. There is a deep peace in knowing that even the most silent places are full of hidden depth. As we drift a little deeper, we consider the invisible forces that still linger in the ancient rock. Even though the planet lacks a global magnetic field, it still possesses small, localized pockets of magnetism scattered across the landscape. These magnetic umbrellas reach up into space, creating small sanctuaries where the solar wind is deflected away from the thin air. They are like invisible islands of protection, remnants of a time when the entire planet was wrapped in a magnetic embrace. The atmosphere is not just a thin veil of carbon dioxide, but a series of layers that each react differently to the sun's touch. We find noble gases like argon and neon drifting in the heights, remnants of the original air that was present when the planet was born. Because these gases are heavy, They have stayed behind while the lighter elements escaped into the void of space over billions of years. They are the chemical memories of a thicker, warmer atmosphere that once supported clouds and rain long ago. In the deep valleys, we see evidence of ancient clay minerals and salts that could only have formed in the presence of standing liquid. These minerals act like a geological archive, trapping tiny bubbles of gas and fragments of the past inside their crystalline structures. We realize that the dry, red world of tonight was once a place of blue lakes and rushing rivers that carved the canyons we see today. The water transformed, hiding itself in the minerals and the frozen depths beneath the surface. The rhythm of the seasons causes the atmosphere to grow and shrink as the polar caps expand and recede. During the winter, so much carbon dioxide freezes onto the poles that the total atmospheric pressure of the planet drops by a significant portion. This massive shift happens in total silence, a global movement of weight that no one is there to feel. It is a testament to the scale of the natural cycles on this world, where even the air itself has a season of rest. We look at the isotopes of hydrogen in the thin air, which show us that the planet once had enough water to cover its entire surface in a shallow ocean. Most of that water was lost to space as the atmosphere thinned, but the heavier elements stayed behind, giving us a clue to the original volume. It is a story of loss and transformation, a world that slowly moved from a wet youth to a dry and frozen maturity. We feel the weight of this vast history as we drift over the silent, empty seabeds. High above the surface, we find clouds made of ice crystals and carbon dioxide that drift through the salmon-colored sky. These clouds are thin and wispy, appearing like delicate veils of silk that catch the light of the setting sun. They move quickly in the upper winds, providing a rare sense of motion in an otherwise static landscape. Even in the driest of deserts, the sky still finds a way to create moments of soft and fleeting beauty for those who watch. We lift our gaze away from the red plains and move into the silent orbit high above the planet, where the perspective shifts from the ground to the vastness of the neighborhood. From this height, we can see the two small companions that follow this world through the dark, like tiny, faithful shadows. These are Phobos and Deimos, the two moons of Mars, which look more like captured asteroids than the large, round moon we know. They drift quietly in the void, bound to their parent planet by the invisible tether of gravity that keeps them in their constant paths. Phobos is the larger of the two and orbits incredibly close to the surface, moving with a speed that seems hurried compared to the stillness below. It is so close that it completes several orbits around Mars in a single day, rising and setting multiple times in the dusty sky. Because of its proximity, the gravitational pull of the planet is slowly drawing Phobos closer every year by a tiny, steady amount. Eventually, in the deep future, the moon will settle forever onto the red ground, becoming part of the world it once circled. Deimos, the smaller moon, sits much further away and moves with a more leisurely and patient pace across the stars. From the surface, it would look like a bright, steady star moving slowly across the night sky over the course of several days. It has a smooth, dusty appearance because its small gravity is just enough to hold onto a layer of fine rock and debris. It is a lonely, quiet satellite that has watched over the red desert for billions of years, witnessing every slow change in the air. Let your jaw unclench and feel the weight of your body resting securely as we consider the vast distances of the solar system surrounding this red world. We are moving in the fourth circle from the sun, situated on the outer edge of the inner rocky planets. There is nothing you need to solve right now, so just let your mind rest as the stars watch from above. Beyond this point lies the Great Divide of the asteroid belt, where millions of fragments of rock and ice orbit in a silent, ancient ring. Mars sits as the quiet guardian of this boundary, a bridge between the small inner worlds and the massive gas giants that lie much further out in the dark. It's another way of seeing the same idea of the planet as a stable protector of the inner solar system's gate. The presence of Jupiter, the largest planet in our system, has played a significant role in the stability and history of this world. Jupiter's massive gravity often tugs at the orbit of Mars, causing its axial tilt to shift significantly over hundreds of thousands of years. These changes in tilt have caused the climate to swing between periods of deep ice ages and slightly milder eras. It is a slow, rhythmic dance governed by the largest weights in our celestial neighborhood, happening far above the red dust. Because Mars sits further from the Sun than Earth, it receives only a fraction of the solar energy that reaches our own home world. This distance is why the world is so consistently cold, and why the Sun appears so much smaller in the copper-colored sky during the day. The light here is thinner and more precious, traveling across an immense distance of empty space to reach the plains. It is a quiet, dim existence that has defined the character and the temperature of the planet for eons. Now imagine the grand and orderly scale of the cosmos as we observe the silent heartbeat of the orbital paths. The solar system is a place of immense order, where everybody moves in its own precise and predictable lane without ever touching. Mars completes its wide orbit at a great speed, yet it feels perfectly still to anyone standing among the rocks. This motion is the steady rhythm of the planet as it travels through the velvet darkness of the outer reaches. Billions of years ago, this world was likely much more similar to our own, with a thick atmosphere and a strong, protective magnetic field. As the planet's interior cooled over time, the magnetic shield faded away, leaving the air vulnerable to the constant stream of the solar wind. Over vast stretches of history, the Sun slowly stripped away the protective layers, turning a wet world into the dry desert we see tonight. This transformation happened so slowly that it would have been invisible from one millennium to the next, a gradual shift into silence. We stand at the very base of Olympus Mons, a volcano so massive it defies our earthly sense of scale. It rises to a towering height 3 times that of our tallest peaks, standing high into the thin air. Its slopes are so gentle and wide that if you stood on its side, the peak would be hidden beyond the curve of the horizon. It is a quiet giant that has found its permanent rest, anchored deep into the silent crust of the world. Think of this mountain as a monument to stability in a changing solar system. Because Mars has no shifting plates, the ground stayed still while the lava piled up for millions of years at a time. This allowed the mountain to grow far beyond the limits of what we know on Earth. In a sense, it is a record of a planet that chose to stay in one place, gathering its strength into a single massive peak that touches the sky. The summit reaches so high that it nearly touches the very edge of space itself, far above the dust. At the top, the atmosphere is so thin that the stars shine with a steady and unblinking light throughout the day. There is no sound here, not even the whisper of the wind, just a profound and eternal silence that covers the crater. It is a place where the chaos of a younger universe has finally settled into a deep, meditative calm. We move our gaze across the equator to the edge of Valles Marineris, a canyon system that would stretch across the entire width of a continent. It is a depth that swallows the light, with walls that drop thousands of feet into the velvet shadows below. This chasm was carved by the stretching of the planet's crust billions of years ago as the world cooled. It is a deep, heavy scar that has become a sanctuary for shadows and still air in the desert. In the deepest parts of this canyon, the air is slightly thicker, allowing for the formation of thin mists that settle on the floor. These mists are made of tiny ice crystals that catch the first light of dawn, turning the dark valleys into a landscape of shimmering silver. This beauty exists in total isolation, a private world that does not require anyone to watch it to be real. It is a reminder that the universe has its own internal rhythm, moving at a pace that is much slower than our own. If your mind wanders, that's okay. Just come back to the steady rhythm of this ancient and patient world. The vastness of these features reminds us that there is a beauty in things that take a very long time to form and even longer to change. In the stillness of the canyon floor, the red dust settles in layers that have remained undisturbed for millions of years. It is a slow accumulation of history, resting in the deep shade where the sun rarely reaches. Looking across these massive landscapes, we realize how small our own daily worries are compared to the scale of the cosmos. This world does not rush to change its shape or fulfill a purpose. It simply exists in a state of quiet and dignified permanence. The mountains and valleys do not ask for anything, they only offer a place for the mind to rest in their steady copper glow. You can feel your own tension dissolving as you realize that you are part of this same vast and orderly story. The silent rocks that sit at the bottom of the canyon are the same ones that have been there since the world was young. They are cool to the touch and heavy with the weight of geological time, anchoring the landscape to its solid and ancient core. We feel a sense of peace in this lack of movement, observing a world that has already found its final resting shape. It is a state of being that values the silence of the night above the noise of the day. The fine red dust continues its slow drift, filling in the small cracks of the ancient stones and softening the edges of the craters. It is a soft and persistent presence that unites the highest peaks with the deepest valleys in a single muted color. Think of it as a silent blanket that wraps the entire planet in a layer of calm, protecting its secrets for eternity. Everything here is connected by this thin layer of history, serving as a silent witness to the passing of ages. We take a final look at the horizon, where the curve of the world meets the dark velvet of the night sky. The stars feel close enough to touch, yet we know they are part of a larger story that stretches far beyond this red desert. The light is dimming, and the world is ready to let go of the day completely and settle into the cold. We are drifting toward the edge of wakefulness, prepared to leave the red plains behind for the softness of our own dreams. We gently pull our awareness back from the massive canyons and the high, frozen peaks of the red planet while the image of the wide, copper-colored horizon begins to fade into the background. We carry the stillness of that distant desert with us, feeling it wrap around us like a heavy, warm blanket as we settle back into the quiet of our own room. The immense distances of space are now behind us, and we are safely home where the air is still and the night is peaceful. The gravity of our world feels steady and supportive, holding us securely as we let go of the day and allow our muscles to soften. We feel the weight of our limbs sinking into the mattress, mirroring the way the red dust has settled on the Martian plains over millions of years of undisturbed history. There is no more traveling to do and no more sights to see tonight. as everything is exactly where it needs to be for you to rest. Your only job now is to simply listen and let your mind rest as the last echoes of the journey fade away. You are resting in your own perfect zone of comfort, where the air is calm and the shadows are soft, while the world outside follows its own steady rhythm. The constant turning of the planet continues without any effort from us, moving us through the dark toward a new morning that is still far away. As we drift further into the quiet, the facts and the stories of the red planet turn into soft, indistinct memories that glow like distant stars. They are part of a larger, silent tapestry that protects us while we sleep in the deep velvet of the night. The silence of the room becomes deeper as the last thoughts of the day begin to dissolve, and we feel ourselves drifting into a state of absolute calm while the night continues its slow path. We are floating in a sea of darkness that is both safe and protective, as the weight of our body anchors us to the mattress while our mind prepares to let go of the waking world. There is a profound sense of peace in this total stillness, and we allow ourselves to be carried away by the gentle current of sleep that is pulling us down into the depths of rest. Every muscle in your body is now completely relaxed, and your breathing has found its own natural and effortless rhythm as the world continues to turn in silence. The red landscape we visited is now just a quiet thought in the back of your mind, while the darkness of the night provides a perfect sanctuary for your dreams. You are safe, and you are held by the steady gravity of the earth, as we find ourselves standing at the very doorway of a deep and restorative sleep. The journey is complete, and the stillness of the stars is all that remains as we drift into the dark. If you are still awake, you can subscribe to Sleepy Night channel for more calm night journeys like this. That was a calm bedtime story about Mars. Now the sound will continue for a while, so you can fall asleep. Good night.